banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
Masih banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
Tes 1 2 dicoba. Tes 1 2. Tes 1 2 dicoba. Tes 1 2 dicoba. Aku ACC Albert. Oh sudah. Tes 1 2. Wah, ini garing banget ini. Tes 1 2. Tes 1 2 dicoba. Tes 1 2 dicoba. Tes 1 2 dicoba. Tes 1 2 dicoba. Tes. Iya. Bagus. Tes 1 2. Yang kamu pegang bagus gak, Jip? Yang kamu pegang mic-nya bagus nggak? Kamu dengerin dari Albert dong. Tes 1 2 3. Nggak ada. Tes setting sendiri. Bagus, Bert. Bisa bagus. Ini cuek. tes 1 2. C I A A E I C kuat C kuat C I A C kuat C I A A I
tes
C kuat C I A I C I A C kuat 2 C C I A A I I I I I A I A dua C kuat C I A I Acep, Acep dong. C, C, dua, C kuat, C, I, A, A, I, C kuat, C, C, A, C, C, C kuat, C, A, C, A, C, C,
Kenyaringan nggak?
C,
Pecah. Berarti
C, C, I, tes, cek, A, C, C,
berarti ini penyaringan.
C, C, I,
Oh gitu. Ya.
oke, C kuat, C,
Cukup nggak kalau yang ini?
C, 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 C kuat, I, cek, cek, A, E,
C, C kalau
C, 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 one, I, dua, C, C, 1 2 dicoba C,
ini cukup.
C, 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 cek, A, cek, C, A, I, C, cek, oh,
Di
1 2 cek, C, 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 E, I, A, I, dua, C kuat, C, C, I, C, I, A, I, dua, C, A, dua, C, A, cek one, cek mic,
Tes, tes, satu, dua, dicoba, tes, gimana? Tes, tes, satu, dua, dicoba, ditanya, tes, satu, dua, tes, satu, dua, dicoba, tes, satu, dua, tes, satu, dua, Assalamualaikum warahmatullahi wabarakatuh, tes, satu, dua, ini bagus nih. Cek, cek, cek.
Masih banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
masih banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
Good morning, ladies and gentlemen. The opening ceremony of this conference is about to start, but we will wait for the other participants to join us in this room. Please be seated and wait. Ladies and gentlemen, the opening ceremony of this conference is about to start. All of audience, please be seated. Para hadirin, acara akan segera kita mulai. Dipersilahkan untuk menempati bangku yang telah disediakan. Cek. Cek. Ladies and gentlemen, the opening ceremony of this conference is about to start. All audience, please be seated and enter the room. Para hadirin, acara akan segera kita mulai. Dipersilakan untuk menempati bangku yang telah disediakan. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. A very warm greetings to each and every one of you. We are delighted to welcome you to the first International Conference on Applied Smart and Green Innovation. Today, 8 June 2022, in Balikpapan, East Kalimantan, Indonesia. I am Raisa Fadila, Master Ceremony of this conference today. On behalf of organizing committee, it is an honor for me to be standing here and welcoming all of audience of this conference. The conference brings together expert, academic researcher, and practitioner who are responsible for developing civil engineering solutions. This event organizing by Balikpapan University, Hasanuddin University, Langlang Buana University, Muhammadiyah Yogyakarta University, Ulster University, and Universitas Kebangsaan Malaysia. Next agenda, we are about to listen to the national anthem of Indonesia, Indonesia Raya. I would like to request your silence. Thank you. All of you, please stand. Thank you. All audience can be seated again. Before we begin our conference, I would like to invite Mr. Kevin to provide together. To Mr. Kevin, time and place is yours.
Let us pray according to our own religions and beliefs before we start this conference. Praying, begin. Praying, finish. Thank you.
Before we move forward to our main session today, I would like to express gratitude for Rektor Universitas Balikpapan, Dr. Insinyur Muhammad Isradi Zainal, Rektor Universitas Hasanuddin, Profesor Jamaluddin Jompa, all the keynote speakers, Profesor Sakti Aji from Hasanuddin University, Dr. David from Yosar University, Profesor Nur Izi from Universitas Kebangsaan Malaysia, all the moderators, and all audience participants and the committee for this conference. Now, we're moving forward for a welcoming speech from our chairman of this conference, Dr. Lucky Carolis. Time and place is yours.
School of Universitas Hasanuddin, the Honorable, our keynote speakers, Prof. Sakti Aji Adisasmita from Universitas Hasanuddin, Dr. David Woodward from Ulster University, and Associate Professor Nur Izi Muhammad Yusuf, the Honorable invited guests and all participants of the first international conference on applied smart and green innovation. It's a great occasion to be able to get together on this joyous occasion. We offer praise and thanksgiving of God Almighty for the power and blessing that have enabled us to attend today even. Let me begin by extending a warm welcome to the audience for the first conference we are hosting. The first International Conference of Applied Smart and Green Innovation 2022 was held as a forum for all international participants from various types of stakeholders who have a potential contribute to innovation in order to achieve sustainable development with eco-friendly and intelligent technology. This conference explores green technology and smart technology from both a basic and complex application standpoint, with a mix of smart technology and green technology. It's feasible to gain several benefits in current day without incurring the significant amount of environmental danger. We are really grateful for the enthusiasm and rises in the event. We have achieved in target 50 registrants with composition of article that are very interesting and discuss various aspects of green and smart innovation. The conference was also attended by present and speakers from various countries. We really appreciate this one of this proof of the green and smart technology research has high attention for various stakeholders. We thank you profusely for the participant and corporation of various parties who encourage and support the implementation of this event. We are expressing our deepest gratitude to the sponsors who have helped support the implementation of this event. We hope that will inspire stakeholders to continue to innovate and excel in research and its application. Hopefully, this event can be a good start for all the attendants to be more advanced and develop in terms of research. On behalf of the entire committee, I would like to welcome you and have a good discussion. This is all I can say. Either are some shortcomings in the delivery. I say my deepest apologies. Thank you for the participation and contribution of all parties who have support this event. Thank you.
Thank you, Dr. Lucky Caroles. Next agenda for this conference is opening speech from Rector Universitas Balikpapan. Ladies and gentlemen, please warm welcome to Dr. Engineer Muhammad Isradi Zaina.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Mr. Rector, Mr. Dean, Mr. Speakers, Dean of Hasanuddin University, distinguished guests and ladies and gentlemen, first of all, I would like to say thanks to the Master of Ceremony who given me a chance to speak to all of you. In this occasion, I would like to say welcome to all of the participants, especially to the Mr. Rector and speaker, and of course for all of the participants. Today, according to the committee, we carry out international conference about applied smart and green innovations. As you know, the green innovation refers to all aspects of innovations related to green product and process. I think this is a good thing for our society nowadays, and of course it will benefit to our nation or also to international community. In this occasion, I would like to say thanks once again to University of Hasanuddin for the cooperations, and I do hope that the next time we can make cooperations, especially about the new capital city of Indonesia. Once again, I say that if you have enough time, please come to my campus. Just now I discussed with Mr. Rector, Mr. Dean, that Balikpapan University will welcome you today, and we can have lunch together, discuss together about the future of our country, especially about smart and green innovations. Only that I can say to all of you, and once again, thank you so much for the cooperations, and we do hope that the international conference today will success, and we wish you a happy international conference. Wassalamualaikum warahmatullahi wabarakatuh.
Move forward to the next agenda. Opening speech from Rector Universitas Hasanuddin and officially open the conference. Please welcome Professor Jamaluddin Jompa.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good morning, ladies and gentlemen, Mr. Rector, and all the speakers. And actually there are two rectors here. One of them is Rector Unibos, just being replaced, but he's still a rector. The Dean and all the participants, I'm looking for Dr. David Woodward. Professor Dave is not here. Is this online? Virtual? Hadir beliau? Online dia. And Prof. Sakti, although he is a professor at UNHAS, but now he is a keynote speaker. So we would like to also say thank you. It is indeed my privilege to be able to stand here and to acknowledge and also appreciate the organizing committee for conducting this very strategic symposium by co-hosting between IDPRC of UNHAS and Universitas Yogyakarta, Muhammadiyah Yogyakarta and Balikpapan and Universitas Langlang Buana and also Universitas Kebangsaan Malaysia, yeah, and also oh, you from sorry, I thought you are Indonesian, so I didn't greet you. And also from Griffith University. It is indeed something that we all need to do together. The world has changed so fast. The challenge has been growing much faster than our ability alone can handle. So I think this is a reflection of awareness of we need to do it together. We just happen to have COVID-19 tragedy for 2.5 years. We couldn't do anything. And I think this is a good momentum for us to aware that the topic of this symposium today is about a green innovation. For me, I'm not an engineering by technical, but I really feel that everybody now needs to think about the future of this planet. So anything that we are doing needs to be sustainable in terms of not only economy, that you're building infrastructure for developing economy, but please remember, we need to make sure this is also sustainable environmentally. Otherwise, it can happen again. Only one type of virus, coronavirus. There are many more millions of viruses out there. Hundreds of thousands species of virus can also act as corona. So it's too dangerous now not to think about green, not to think about the future of this planet, the sustainability of planet. And I think the topic has been very good today. That smart technology means really, you really understand what you are doing. To me, in the past, we are stupid technology, sorry to say. We get all of this oil from the nature, the fossil based fuel, and then we polluted the air. We create, basically, we change the climate. We create green gas houses, and so the temperature becoming crazy, going up a lot more than the capacity of the nature to adapt. And that means we create unbalanced ecosystem where we are part of the ecosystem. The problem is we thought ecosystem is outside of human being, and I think that's very difficult for us to understand if we call that smart. So it was a stupid technology that we had in the past. Now the time, and I think we better do it now. So I believe this symposium, hopefully not only talking about science, but please bring the spirit of just recent experience. That we really need to be serious, not only to find the new technology that we can make faster, we can make growth stronger, but we forgot that we are nothing if the environment is not suitable. What's happening to the virus that we were so afraid and we had so many lost. I lost my 5 teens. I lost my family, many of my family, relatives, friends, and because we made a mistake in the past. It's a stupid technology. Well, I say stupid because we're now talking about smart technology. Just say it was in the past. Let's now start with the smart technology. Because this virus is supposed to be living within the animals. We as a human being, a lot of virus associate with us. A lot more virus cells compared to our own cells. And that's very normal, that's life. And so does the animals, has the virus living with them, no problems. But the problem is when we change this ecosystem, we change this world, we change this climate, the virus associated with the animals become a bit confused. What's happening to this? So that they mutate. So the mutation of this virus becoming problems because then they can move to the people, to the human, right? We call zoonosis. And that's become problem for us because we cannot adapt. We cannot live with this virus, so that we become infected and a lot of fatalities. Why I mention this? I'm not a medical doctor. I'm an environmentalist. But without aware, without knowing this, I don't think we have the spirit of developing smart green technology, because we will say, oh, this is so expensive. It's so expensive to build up, for example, building that use light without this kind of light. Sorry to criticize. We need to open the window. We have free light from God, from the nature. And that's, I think, the smart technology all about. We close all the windows and we turn on the light, and we produce that light from fossil fuel that polluted the air. Is that what we call smart? No. Let's think about it. I'm not engineering again, so it is my apology if I made a mistake. But you need to answer my curiosity. So, my friends, my college, I'm coming from Makassar today. I'm still very tired because yesterday my university was visited for the first time ever by Prime Minister of Australia. Yeah. It wasn't easy to convince him to come, but I was so happy to get him emotionally with friendly but very smart conversation talking about climate change adaptation and mitigation. And we need technology. We need smart technology. We need smart infrastructure. We need smart energy. The smart means understanding that this world is changing very fast. Coral reefs, I'm marine biology. The coral reef were so suffering because the stupid technology. Coral reef since 1998, for the first time ever, get mass bleaching. In Great Barrier Reef, when I was in Australia, maybe about 40% get bleached, and maybe 50% of the get bleached ones, severe bleach, and a lot of them actually die. And from that time until now, mortality rate becoming higher and higher. And in the future, maybe there is no such coral reef in the world if the scenario of IPCC happening without commitment of all the countries to reduce emission. And I think as a coral reef scientist, I really hope that you guys, we all as an engineer that we are talking about today, green innovation, let's find a solution together. This is the purpose and this is the role of scientists. And this is why we come here. We need to spend energy, we need to sacrifice our time with our family Although you are so tired, let's come here because we have an emergency situation. I call this emergency situation. We need a smart green innovation. We need to have smart green technology. So let's work together. I do hope this is a good platform to exchange between us, within us, and not only idea, but let's also make a roadmap to do research, to provide solution, and to also provide a policy recommendation. Please, as a scientist, we have been doing so many publications, but the question is, what is the impact of the publication? Have we recommended to the right appropriate agency of government to change the way the policy in the past? My friends, we are now close to the new capital of Indonesia. I'm planning to visit, but maybe only in the border or close, yeah. I haven't been able to directly to come to IKN, Ibu Kota Negara, ya, baru, Nusantara. But for me, this is a new civilization that we need to create. So Pak Sakti and the group, this IDPRC, I think if I may task, we need to ensure this new capital also mean new civilization. Do not allow the stupid technology also to happen there. Yeah. So we now have two technology. One is smart and one is not very smart. We don't want to say stupid because maybe some of them you get offended, ya, tersinggung. Tapi karena ini sangat serius, saya agak emosional ketika melihat kenyataan. Kebetulan saat ini kita lagi menyusun G20 statement. I'm part of the team to make that statement. So we really need to recover, yeah, not only from COVID, but also from climate change impact. And we need to recover together, but we need to recover much stronger than ever. And that's very, very strong message from G20. So Bapak Ibu, kita harus pulih dan kita harus pulih bersama-sama. Dan kita harus pulih jauh lebih kuat dari itu. Dan saya kira hari ini, simposium ini, it happened to be very close to the new capital. Again, I hope that when we talk about infrastructure, we do need to make sure this is a green technology that we are going to apply in our new civilization. Peradaban baru. Tidak mungkin bisa kita membuat perubahan tanpa tekad yang kuat untuk merubah desain, merubah mindset, dan juga saya kira dengan political will yang kuat, mudah-mudahan kita bisa memastikan bahwa ibu kota negara ini betul-betul terjadi. Pak Rektor, kita harus kawal bersama. Tepuk tangan dulu buat Pak Rektor dan kita semua. We need to make sure that this is a new capital is happening. This is not only that we want here in this room, but this is a political decision. And political decision need a political negotiation, political approach, and we need to find a way to make sure that this happens. So finally, I do appreciate all the participants, especially my college, all the speakers who really wanted to spend time here, far from your home. I'm not sure whether you bring your own family, but in most cases, we came alone here to sacrifice time, and that's very, very meaningful for us because you do have commitment for this. And I do hope that this is a platform that we will create because this is the first international conference on applied smart and green innovation. Pak Sakti, first means there will be the second, there will be the third, and so on. Please don't make me embarrassed. Tolong jangan membuat saya malu, membuka yang pertama, dan setelah itu tidak ada lagi yang kedua dan seterusnya. Because I have an experience in the past. Fortunately, I wasn't the one who opened that first symposium, but I was happened to be one of the committee. And until now, I remember that embarrassing situation in Makassar. We opened that symposium, very big name, first international symposium. I didn't want to mention because you will understand who are they. But it was the first and the last. hari ini kita akan membuka ini dan saya sangat berharap jangan sampai rektor baru ini dan dekan baru, sorry Pak Dekan saya lupa. Tepuk tangan dulu buat Pak Dekan baru untuk tekniknya. Bersama-sama datang ke sini membuka sesuatu yang pertama dan yang terakhir. Ya, itu tidak boleh terjadi. Sehingga from now on, please design for the second, design for the next, and make it smarter, make it bigger, and make it much more influential, and have a better impact to the policy, to the infrastructure change, and so on. So I do hope everybody, wherever you're coming from, dari manapun Bapak Ibu teman-teman datang, tetap we need to make sure that you enjoy your time here. We are doing this seriously with your full heart, but you also need to make sure that you are happy. We don't want everybody just to worry that we forgot that we are human beings. Also, we need to be happy. So please enjoy your stay here in Balikpapan. It's a nice city. I really love the city, but I just didn't have much time to enjoy this time. But in the near future, the rector promised me to get around, and hopefully next time we can have a much better time. So with that, I hereby declare the conference officially open with Bismillahirrahmanirrahim. Terima kasih. Lebih kurangnya mohon maaf. Assalamualaikum warahmatullahi wabarakatuh.
Once again, give a big applause for Rector Universitas Hasanuddin, Professor Jamaluddin Jomba. Now we are going to move forward to the main agenda of this conference. Presentation and explanation from our keynote speaker for today. Now I'll introduce our moderator who will be guiding the conference. Please warm welcome for Dr. Sigfred. Dr. Sigfred is from Institute of Road Engineering in area interest, pavement design and pavement management system. Good morning, Prof. Sigfred. Give an applause for Mr. Sigfred. He will be moderator for the first keynote speaker. Okay. Good morning, Mr. Sigfred. The conference is in your command now. We will give you 20 minutes for presentation explanation and 30 minutes for question and answer.
Okay. Good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Now we are in the first session of keynote speech. I'm Sigfrid from Institute of Road Engineering and acting as a moderator for this session. Actually, we have two presenters. First, Professor Sakti Aji Adisasmita and Dr. David Woodward from University of Ulster, UK. I invite these students to have a seat next to me. Prof. Sakti, David.
Please give an applause for Mr. David and Mr. Sakti. kasih atas kedatangannya Bapak Rektor Universitas Balikpapan dan Rektor Universitas Hasanuddin, Bapak Dr. Muhammad Isradi Zainal dan Profesor Jamaluddin Jokpa.
Dek, tolong dimatiin bisa nggak ya? Okay, before we start, just relax and take a deep breath. Santai-santai aja, Pak. Okay. Let me first introduce these two gentlemen to all of the participants. The first one, Professor Sakti Aji Adisasmita, was born in Makassar and he got his first and second degree from Civil Engineering Department of University of Hasanuddin. And then he continued his study to Australia and he got his second master and PhD from University of New South Wales. He then went back to Makassar to continue his career as a lecturer. During his academic career, he got the professorship in 2014, I think, as far as I remember. His main research is on transportation and aviation engineering. He has supervised many PhD students, including one of his beloved student, the Dr. Lucky Caroles. Now he's head of our Center of Studies. He's gonna present a paper called Smart and Green Technology in Airport. It is something we are dreaming of in next 20 and 30 years time. I hope Indonesia will have a green and smart airport in next 20 and 30 years. Okay, that's all about Professor Sakti Aji Adisasmita. And next to me is Dr. David Woodward. He was born in Belfast, UK. He got his first, second, and PhD degrees from University of Ulster, Belfast, UK. Then he continued his career as academic staff, as a lecturer in, it was School of Bioenvironment. Now the name has been changed a little bit. I can't remember it. His main research is on pavement material, contact stress between between tires and road surface, and also skid resistance. He has supervised many research students, including myself, 27 years ago. And David Woodward also worked for some consultant in UK, where his recent project was Mandalika circuit, something that we are proud of. Indonesia is well known now, especially for superbike lovers, because of Mandalika. And the title of his presentation would be UK experiences in applying stone mastic asphalt for heavy loaded traffic and also for less noise pavement. He will also touch some of his experience in Mandalika. So if we have question later on about the SMA, because SMA is very good. It's very good mix for asphalt surfacing. It's well known in UK, in Germany, and many other Western countries. But I'm working for public works, but we in Indonesia have tried to apply this stone mastic asphalt in 2000 up to 2004, but some of links are failed. We can discuss about the stone mastic asphalt. Okay, that's all about these two gentlemen, and now let's start this conversation of keynote speech. First, Prof. Sakti, time is yours. You have 20 minutes for presentation, more or less, please. More or less. You said less. Okay, Prof. Sakti, time is yours.
Saja ya, Pak. Ya. Terima kasih atas kesempatan yang diberikan, atas kehadiran semua teman-teman. Assalamualaikum warahmatullahi wabarakatuh. Saya kira I'll give a short presentation as only short conversation and long time. Short presentation, and I just give important points. Okay. Yeah. The chosen topic in this conversation is megacity and mega airport, futuristic innovation in aviation and the airport world. Why I choose this topic? Because I inspired with a book entitled Megacity and Mega Airport, written by Sakti Aji Adisasmita in 2012. This book contains quite many important points, such as airport master plan, megacity, mega airport, airport technology advance and city growth, and then aviation and airport business, and also challenges faced in realizing of megacity and mega airport, and etc. etc. Mengapa judul ini saya pikir penting? Karena Indonesia adalah negara kepulauan. Untuk mempertemukan atau untuk menjangkau pulau-pulau di Indonesia, the fastest way is air transportation system to unity, to connect in many regions in Indonesia. What is the first point is megacity. Yeah, we know that population growth year by year, connectivity, then city increase year by year from small city, medium city, kemudian big city, and then metropolitan city, and then megapolitan, and then become megacity. We know that megacity is urban area. Typically, the population more than 10 million and more. And also, megacity is a rapidly growing city. Megacity can consist of single urban area or two or more urban metropolitan area converge upon one another. Jadi megacity ini adalah kota yang cukup besar, bahkan sangat besar, di mana populasinya itu adalah 10 juta ke atas ya. Jadi Indonesia harus bersiap-siap diri, kita harus berpikir jangka panjang ke depan, future, terkait perkembangan kota. Karena kota berkembang, kemudian kendaraan bertambah, problemnya adalah kemacetan yang semakin macet dan semakin menjadi-jadi. Ya, lanjut. Kemudian this is the world megacity yang pertumbuhannya mulai dari data 2011 sampai di future sampai 2025. Half of this urban agglomeration is in China and India. Jadi sebagian besar itu kota-kota megacity itu berkembang di Cina yang banyak di China dan di India. Kemudian other countries consist of one megacity or more megacity, ada di Tokyo, ada di Pakistan, representing in Karachi, kemudian ada di Mexico City, Amerika, kemudian di negara-negara lain. Tokyo saat ini adalah the first rank of megacity, mencapai 37 juta penduduk. Bagaimana dengan Indonesia yang diwakili oleh Jakarta? Saat ini Jakarta sudah termasuk megacity karena sudah mencapai, dari data yang kami peroleh saat ini, Jakarta itu sudah 11.2 million people. Kalau di Jabodetabek itu sudah mencapai 29.1 million people. Jadi bisa dibayangkan dengan terjadinya megacity di Indonesia, di Jakarta dan Jabodetabek, tidak tertutup kemungkinan megacity yang lain di Indonesia akan berkembang dan akan menjadi kenyataan. Lanjut. This is the growth projection in selected ASEAN cities. It is predicted that Jakarta will be the first rank on megacity in Asia, approximately 35.5 million people. Jadi Jakarta will replace Tokyo as first rank of megacity in Asia. Lanjut. Nah, bagaimana megacity ini? Seperti tadi yang Pak Rektor Unhas sampaikan bahwa harus berwawasan lingkungan. Jadi megacity ini perlu didukung oleh konsep green city, di mana important points of green city itu adalah make it easy to get around without a car. Jadi memang terutama di CBD, daerah pusat kota, kita harus mulai meminimalisasi penggunaan kendaraan pribadi dan menggantikannya dengan angkutan massal dan kendaraan yang sehat, jadi transportasi sehat. Kemudian add EV charging station, kemudian access to public resources and green spaces. Jadi akses to public, aksesibilitas dan ruang terbuka hijau. Kemudian improve water conservation and wastewater management. Ini juga salah satu important point untuk green city concept. Kemudian mensupport urban farming dan implement green architecture. Lanjut. This is example of the concept of green city, which is compact, sustainable, integrated. Unsur-unsur atau komponen daripada green city yang lengkap itu diantaranya konsep kota itu ada urban farm-nya yang nomor 1 itu, kemudian ada greenhouse di nomor 2, kemudian ada vertical farming di nomor 3, ada urban bees, ada water storage, ada trees package dan sebagainya. Jadi ini adalah example daripada green city yang compact, integrated, sustainable. Lanjut. Nah, apa kaitan antara megacity, what is the connectivity of megacity and mega airport? To connect the megacity and mega airport adalah dengan accessibility, kemudian pergerakan kendaraan, pertambahan manusia dalam suatu kota, maka dibutuhkan need a large of airport, which is need quite amount of space of land. Jadi ini adalah hubungan antara megacity dan mega airport. Kota-kota berkembang, pergerakan bertambah, penduduk bertambah, tentu membutuhkan bandar udara yang lebih besar. Nah, ini adalah data terkait aviation megacity dari 2014 dan kemudian diprediksi 2034. Dalam data disampaikan bahwa world airport traffic growth by 4.1% per year, dan kemudian in Asia growth for 6% per year. Nah, karena perkembangannya sangat signifikan, apalagi setelah COVID mulai mereda, pergerakan manusia dari kota ke kota, kota ke mancanegara, antar negara itu berkembang dengan cepat. So, to cope with traffic growth, airport are expected to invest 1.8 billions until 2020. Jadi dibutuhkan dana yang cukup besar, airport semakin besar, tetapi limitasi dari tata guna lahan. Dan kita lihat di tahun 2014 itu sudah ada 47 aviation megacity, dan diprediksi in 2034 there are 91 aviation megacity in the world. Jadi perkembangannya dalam tahun ke tahun itu, perkembangan dari megacity itu berkembang cukup pesat, sehingga megacity menjadi sangat padat, traffic congestion, dan membutuhkan dana yang besar, di mana 2014 itu daily passenger itu to and from how long distance in megacity itu ada 0,9 million people. Jadi ada 0,9 juta pergerakan orang per hari antar airport. Nah, diprediksi di 2034 itu perkembangannya menjadi 2,3 juta pergerakan penumpang dalam satu hari. Jadi bisa dibayangkan pergerakan manusia, people movement itu increasing significantly, sehingga kita bisa bayangkan pergerakan yang begitu cepat, begitu banyak 2 tahun terakhir ini, maka COVID-19 itu bisa berkembang begitu cepat antar kota, antar negara, antar benua dengan banyaknya pergerakan ini. Lanjut. Nah, kalau tadi sudah saya sampaikan bahwa megacity berkembang dari satu kota menjadi kota besar, megapolitan, megacity, kemudian konektivitasnya dibutuhkan airport yang lebih besar. Nah, ini adalah the concept of airport city and aerotropolis introduced by John Casarda in 2000. John Casarda developed bandar udara. Bandar udara itu dilengkapi dengan commercial facilities, di mana airport city itu ditunjang oleh commercial facilities tidak hanya di dalam bandar udara, tetapi di sekitar bandar udara. Dan konsep aerotropolis malah commercial facilities-nya itu berkembang jauh beyond the airport sampai mencapai 30 km keluar, di mana commercial facilities-nya consist of mall, hotels, leisure, tourism area, housing, industry, trade, and logistic park, and so on and so on. Jadi diharapkan dengan perkembangan komersial fasilitas di dalam bandar udara, di sekitar bandar udara, dan di luar bandar udara sampai 20-30 km keluar, komersial facilities-nya itu menjadikan revenue yang cukup besar untuk perkembangan bandar udara. Bandar udara di luar itu mengandalkan komersial facilities, sementara di Indonesia pada umumnya komersial facilities ini atau revenue dari sisi darat masih mengandalkan sekitar only 35% lebih mengandalkan revenue di airside-nya sekitar 65%, sehingga banyak bandar udara belum bisa membiayai sendiri bandar udara tersebut. Jadi inilah konsep yang dikembangkan oleh John Casarda terkait Airport City and Aerotropolis. Nah, Mega City perlu ditunjang oleh Green City, Mega City dan Mega Airport perlu ditunjang oleh Smart City dan Smart Airport. Apa komponen utama daripada Smart City? The main components adalah Smart Government, kemudian Smart Living, Smart Economy, Smart People, dan Smart Environment. Inilah main komponen dari Smart City, seperti yang tadi disampaikan oleh Pak Rektor, bahwa harus smart dan berwawasan lingkungan. Lanjut. Kemudian Mega City, Mega Airport harus ditunjang oleh Smart City dan juga harus dilengkapi oleh Smart Airport. Apa saja komponen utama dari Smart Airport adalah Smart Parking, kemudian Waste Management, ada Public Safety, ada Video Analytic, kemudian Smart Pole, Smart Grid, kemudian ada Smart Lighting, Intelligent Traffic Management, ada Drone Inspection, dan sebagainya. Saat ini PSP 4 di bawah kepemimpinan Pak Luki, Pak Dr. Luki, merencanakan ada suatu inovasi untuk membuat smart parking ya Pak Luki, dan diharapkan Pak Luki di bawah komandan Pak Luki, smart parking yang direncanakan oleh PSP 4 bisa mendapatkan hak patennya. Jadi Mega City, Mega Airport, Green City, Smart City, dan Smart Airport supaya menjadi suatu kesatuan yang tidak terpisahkan. Lanjut. Nah, kita melihat bagaimana dengan Indonesia. Indonesia is a archipelagic country, consists of 17,000 island, extended 5,100 around more than 100, around 5,100 something kilometer from east to west. So air transportation system will connect it very fast to reach all the region in Indonesia. Dan di Indonesia the fastest way-nya adalah air transportation system yang bisa mengkonektivitas antar pulau. Dan di Indonesia consist of around almost 700 airports, di mana around 35 commercial airports managed by PT Angkasa Pura dan PT Angkasa Pura I dan Angkasa Pura II. Jadi untuk menghubungkan seluruh pulau di Indonesia, subsektor transportasi udara lah yang bisa menjangkau dengan fast, secure, safety, dan comfort. Jadi subsektor transportasi udara yang menjadi andalan untuk menghubungkan antar pulau, terutama untuk transportasi penumpang ya. Lanjut. Nah, kalau tadi sudah disampaikan dalam slide sebelumnya terkait konsep yang dikembangkan John Casarda terkait Airport City dan Aerotropolis, bagaimana dengan di Indonesia? Ini beberapa contoh dari beberapa airport di Indonesia. Saya ambil saja ada 4 ini yang mewakili wilayah barat, wilayah timur. Kita lihat bahwa Grand Design of Soekarno-Hatta Airport itu saat ini sudah ada pengembangan sampai Terminal 3 dan Runway 2, tetapi ke depan akan dikembangkan lagi Terminal 4, Runway 4, itu ya. dengan membutuhkan luas lahan 800 hektar lebih. Kemudian di Kuala Namu Airport itu sudah dikembangkan pula dengan konsep aerotropolis yang tadi sudah slide sebelumnya. Kemudian di Kertajati juga sudah dikembangkan konsep Aero City Airport, di mana Aero City Airport ini dikelilingi oleh fasilitas-fasilitas komersial. Ada green area-nya, kemudian ada tourism, ada business area, ada central park, ada residensial dan sebagainya. Dan tentu di wilayah timur Sultan Hasanuddin Airport itu sudah mengembangkan pula konsep Airport City. Itu rencana dengan 2.200 hektar. Pengembangannya terdiri dari hotel, mall, logistik, daerah turis, daerah rekreasi, dan daerah komersial lainnya. Nah, kendala utama yang dihadapi dalam airport development di Indonesia ini adalah belum teroperasikannya aksesibilitas yang memadai, baik di Kuala Namu, di Kertajati, maupun di Hasanuddin. Masih terjadi banyak titik-titik kemacetan, sehingga untuk pengembangan ke depannya adalah mass transportation adalah menjadi pilihan utama. Nah, terkait aksesibilitas jalan, terkait highway engineering, terkait pavement engineering akan dijelaskan lebih detail oleh Pak Peter, Pak David, dan Prof. Isi. Lanjut. Setelah tadi Indonesia bagaimana, kemudian contoh-contoh airport yang mengikuti konsep yang dikembangkan oleh John Casarda. Bagaimana dengan how about the connectivity in East Kalimantan Province? Ini sangat penting sekarang karena in East Kalimantan Province ini ada 3 city, 3 kota merupakan super hub connectivity di antar pulaunya. Ada Balikpapan yang kita sama-sama hadir di sini. Balikpapan itu merupakan secara garis besar atau secara general itu Balikpapan merupakan logistik center, kemudian ada sebagai pusat petrochemical center, dan kemudian di Samarinda ada sebagai pusat government center, kemudian ada mining center, dan pusat pemerintahan saat ini. Jadi di 2 kota yang eksis saat ini, di Balikpapan itu ada Sepinggan Airport, dan kemudian di Samarinda itu ada AP Pranoto Airport yang eksis. Di mana Balikpapan Airport ini, Sepinggan itu melayani serve 30 million per year for passenger, dan di Samarinda melayani serve 20 million per year. Jadi bisa dibayangkan perkembangan penumpang, pertambahannya, dan konektivitas lalu lintas penerbangan udara akan semakin padat. Dengan hadirnya Capital City of Indonesia di IKN, itu akan direncanakan ada VVV Airport untuk tamu-tamu negara, dan it is predicted that 200,000 people will move to IKN. Jadi bisa dibayangkan perkembangan kota nanti akan semakin padat, maka dibutuhkan airport yang terintegrasi, komprehensif, multimoda dalam suatu tatanan bandar udara multi airport system yang harus sesuai standar internasional dan standar nasional. Nah, seperti yang kami sampaikan tadi bahwa konektivitas mega city, mega airport perlu ditunjang dengan aksesibilitas yang optimal, dan dibutuhkan need to implemented smart multimodal system where the smart multimodal system, the main component are smart infrastructure, data integration, smart services. Dan di mana, for instance, smart infrastructure consists of connected and sustainable multimodal transport, jadi terintegrasi, automatic fare collection, automatic traffic signal. Jadi smart multimodal system ditunjang oleh ITS, transportasi cerdas. Nah, hal-hal inilah yang harus diimplementasi di Indonesia agar airport infrastructure can operate maximal and optimal. Nah, bagaimana terkait bandar udara yang futuristik, future, dibutuhkan konsep-konsep inovasi. Konsep inovasi ini introduced by Hesseling from Deutsche expert. He introduced this concept circular airport. Jadi memperkenalkan metode atau konsep circular airport yang bisa implemented, maybe yes, maybe no, but maybe in 2050, hope this concept will implemented. Tesis daripada circular airport menurut Hesseling ini untuk meminimalisasi traffic jam di airspace, traffic jam, kemudian meminimalisasi dampak lingkungan, kemudian bisa mengoptimalkan aircraft fly and land in many direction. Ya, itulah konsep salah satu. Itulah beberapa dasar-dasar konsep mengapa sampai terlahir inovasi terkait circular airport ini. Karena terjadinya kemacetan di udara, meminimalisasi dampak lingkungan, meminimalisasi air pollution and noise. Jadi konsep ini diperkenalkan. Ya, lanjut. Salah satu inovasi airport infrastructure yang lain adalah for the futuristic airport itu adalah bagaimana terkait vertical airport ke depan, di mana big airport atau airport yang luas itu membutuhkan space itu yang masif, di mana kita tahu bahwa persoalan terutama di Indonesia ya adalah persoalan pembebasan lahan. Maka dengan konsep vertical airport ini diharapkan menjadi suatu solusi. Jadi vertical airport vertical structure, kemudian vertical airport structure ini dilengkapi dengan fasilitas komersial, ada mall, ada kuliner, ada fasilitas komersial lain yang direncanakan, dibangun, dikembangkan secara vertikal. Kalau tadi konsepnya mega airport itu, mega city aerotropolis itu adalah pengembangan airport secara horizontal, diharapkan ke depan futuristik airport futuristik ke depan itu bisa dibangun konsep vertical airport tersebut. Jadi ada circular airport, ada vertical airport yang merupakan futuristik konsep. Apakah akan bisa diimplementasi ataupun tidak, tetapi konsep ini bisa menjadi dasar untuk pengembangan ke depan. Lanjut. Kalau tadi airport infrastructure-nya futuristik innovation-nya, Airbus juga merencanakan beberapa inovasi daripada moda transportasi udara itu adalah Airbus juga merencanakan konsep terkait bionic Airbus yang diharapkan bisa terimplementasi di 2050, di mana dia mereduksi fuel consumption dan berwawasan lingkungan. Kemudian inovasi yang lainnya, lanjut. Ini tadi Airbus, kemudian ada Lockheed Martin Aerospace Company juga itu merencanakan untuk mendevelop box wing concept untuk bisa diimplementasi, mudah-mudahan di 2025. Jadi itulah tadi konsep-konsep terkait airport structure, airport infrastructure, vertical airport, kemudian circular runway, dan kemudian ada moda transportasi udara terkait pesawat yang bisa menjadi pilihan masa depan. Ya, lanjut. Mungkin bisa sebagai penutup kita bisa melihat bagaimana video ini terkait circular airport. Bisa diputar ya? Tidak bisa ya? Oh iya, oke. Oke, terima kasih. Slide terakhir. Terima kasih atas perhatian teman-teman. Jadi presentasi saya ini jangan dilihat judulnya, jangan dilihat isinya, lihat di slide terakhirnya. Ya, oke, guys, thank you.
Okay, thanks Prof. Sakti. We learn much from Prof. Sakti about aviation, megacity, smart cities. Smart city, there consists of smart parking, IoT, AI, ITS. These all are the challenge for us as academic people to do some further research on ITS, on AI, artificial intelligence, on IoT. But the first one has been taken by PSP4, smart parkings. Okay, also the futuristic airport, circular airport, vertical airport. To be honest, I cannot imagine how circular airport, how vertical airport, because he said that it will be realized in next 20-30 years. I don't know I still alive at that time or not. Okay, there's second presentation is David Woodward with UK experiences. If you all participants have question, please hold on first. We can discuss it in question time. So David, you have 20 or to 30 minutes to do presentation. I really love if he do presentation, because when I was a student, he always teach me many things and through presentation. Okay, he is a good teacher. Okay, David, time is yours.
Is this working? Yeah. Okay, it's good to be here. Thank you very much, Dr. Siegfried. Dr. Siegfried was one of my former PhD students, and it is very good to be invited by him to speak at your first conference here in Balikpapan. I'm no stranger to Indonesia. I've been here many times, and what I'm going to talk about mainly this morning is Mandalika. I think everyone in Indonesia knows about Mandalika. It was a massive project for the country, showing that Indonesia is on the map through MotoGP and World Superbikes. So what I'm going to do is basically give a case study which is part of the project that I was involved in. So, okay, so I'm going to start very simple. what's stone mastic asphalt? You're not all engineers here. You may not know what SMA is. So very, very short brief, and then we'll go on to Mandalika. And by the end of this presentation, everyone will know what SMA is. Okay, so split mastic asphalt, it's German, developed about 50 years ago in Germany. It was originally developed to offer something that gave a lot of resistance to tires with little metal studs that the Germans used in the winter because of all the snow. Germany also is a very warm summer, so they realized very quickly that it stood up to very warm temperatures. Okay? Because of that, it's got a high stone content, and it has become very widely used around the world. And I'm interested to hear what Dr. Siegfried has said, is that it has had different success here in Indonesia. Okay? But the thing about SMA is that, so depending on the stone size that we use, you can make it thin, you can make it thick, and you can use it for the different layers in a road construction. And because we can do that, we can then design it to give different properties. In my country, we design for skid resistance, we design for noise, we design for rolling resistance, and we design for rut resistance. So all the properties that apply to the title here, which is smart and green. Okay? So this is like a class 101 on SMA. It is simple to make, and more importantly, it is simple to get wrong. Okay? People think they can make SMA, and a lot of times it goes wrong for many different reasons. Okay? And we're going to use Mandalika to illustrate all the different steps that you need to consider for SMA to work correctly. So it's basically, it's very, very simple. You make what's known as a stone skeleton. You take large aggregate and you make a skeleton. And in between the holes, you fill in with a mastic. And the mastic is fine aggregate, or it could be sand, or it could be bitumen. And then to hold everything together, you have to use a modified bitumen. And you can put polymers into the bitumen, and then normally you have to add fibers to hold the bitumen on the coarse aggregate. Otherwise, the bitumen just flows off the aggregate. Okay, so every one of those steps has to be correct. Otherwise, it will not work. Okay, so if you remember that, we'll follow through this over the course of the presentation. So this is just a very simple demonstration of the importance of the coarse aggregate. It's a little stress thing where the point-on-point contact of the aggregate particle, and if one of those aggregate particles, there's a problem with it, the whole structure falls apart. So one bad stone in a piece of SMA, and that will lead to failure. Okay, so aggregate quality is critical. So I don't know if you, so as I said, we've been working with SMA for about 25, 30 years in the UK. And over the years, we have developed the basic SMA into a lot of different specialist products. And these are just 4 products. I don't know if you can see them from the back, but there's a product there which is developed for skid resistance. There's a product developed to be rolling resistance, fuel efficiency. Now, before, I could give a talk about these 4 products, but I'm not going to. What I'm going to talk about is Mandalika. Because all of those 4 products are made with the same ingredients. It's the same aggregates, the same bitumen, the same filler. You combine them in slightly different ways in SMA, and you can make all of those different specialist products. So as regards the new city which you're going to build here, if you want noise, you can make SMA which is quiet. If you want rolling resistance, better fuel efficiency for your vehicles, you can make it fuel efficient. If you want more safety, skid resistance, you can make it by combining these aggregates in different ways. So I'm going to talk about Mandalika. Anybody been to Mandalika? Did you watch it on the TV? Did you watch the MotoGP? Okay, did you watch the World Superbikes? Maybe not. Okay, I was there. Okay, did you know that before MotoGP, 1.6 kilometers of the track was replaced? Did you know that? Okay, some people knew. Okay, there's a lot of information on the internet about Mandalika, and then there's other material. That's what I'm going to talk about in this presentation this morning. So I'm going to illustrate some of the different issues that you have to consider if you're going to make and lay SMA using Mandalika. Okay, so anybody recognize the person in the middle? That's our friend Rara. Okay, we were in Georgia 3 days ago, and I got a WhatsApp from Rara. Hello, Dr. Devi. I hear you're in Georgia. Rara helped us in Mandalika. She helped during the MotoGP. A very, very special person. So in terms of Mandalika, it was built during COVID. I was in Lombok for the first meeting in January 2020. And then the plan was I would be back along with the company that I work with and the other overseas consultants. And we would build Mandalika then over the next summer, but that didn't happen with COVID. It was surfaced with a 10 mil SMA. The coarse aggregate was brought in from Palau Island. And there was a heavily modified PMB bitumen sourced from Jakarta brought in. Now, Lombok, Mandalika is an island, and that posed a lot of problems with the construction of the track. Okay, so we had to bring in a mobile asphalt plant that was big enough to make enough asphalt to lay the asphalt in 5 segments, so we didn't have joins. The SMA was finished in August of last year. There was no traffic until early November. And then the 3 weeks running up to World Superbikes, the line markings and all the rest was put on the track. So the track sat in the sun for 3 months. There was nothing driving or riding on the track. Okay, so nothing happened on the track. I got some photographs in the UK sent early November, and there were concerns with these little marks appearing on the surface. When I got to the track with COVID holiday in Jakarta for 3 or 4 days, I discovered or confirmed that there was a problem. In those 3 months between August and November, the track was starting to fail simply by sitting in the sun. So I don't know if you can see this at all with the light, but these are some photographs in early November. And there's little light-colored particles. Those are the particles of stone which are starting to fail. You can flick them out with your fingernail. In different tracks, different places around the track, the problem got worse. Okay. And in some places, probably half the track had failed within 3 months of not being used. Okay, so we were there initially to do tests for the first race. We were checking for flatness on a motorbike track. 2 millimeters is considered a bump. Okay, MotoGP, 2 millimeters, a rider will complain about a bump. We were tracking for texture as well, because skid resistance, water on the surface, all of that was really important. Sand patch, very basic tests, and everything was coming out good. The track had been built exceptionally well. Okay, but there was this problem with the surface. There were many, many people involved in its construction during COVID. There were many people doing tests, densities, compactions, voids, compositions. Everything was coming out good. But when we got there and had a look at the surface was failing. Okay, the president turned up. He had the first lap. My photographs. This is his little green motorbike. A very nice gentleman. Very, very nice person. Very nice person. Okay. I had some local interest in World Superbikes. This is someone who lives in my country, a guy called Johnny Ray. And he won both races at Mandalika. And then we had the new world champion, the Turkish guy. So that was the third week in November. The track had been laid in August. It had one weekend race, and we were starting to have problems with the surface. And these are the first attempts to try and fix the problems. We called it Magic Patch. So this was towards the end of November. Come on another few months. For MotoGP, they had their pre-season testing. And basically, the bikes during pre-season testing were very bad to the surface. Okay, and we had a lot of problems with the surface. Basically, everything there which is a light color is weathered aggregate. It's a problem. And as you can see in that photograph, there's over 50% of the aggregate has failed since August. We took cores. Say I've got the cores back in my lab for analysis. So the decision was made after the pre-season test to replace or resurface 1.6 kilometers from turn 16 to turn 5. So we had to bring in all the equipment again. The equipment that had been brought in, construct the surface in the summer of 2021, had to be brought back to Lombok. A big logistical issue, big problem. Okay, we wanted to know what the condition of the surface was, so we did a complete LiDAR analysis of the surface, just to get the profiles and the heights and see whatever issues, and we used that to program the milling process. We had to bring in milling equipment and get it calibrated. We had to start and we had to decide how much of the asphalt to mill out. Meanwhile, we had to source aggregate. And again, we waited on aggregate coming in from Palau. And this is the analysis of the Palau aggregate again that we received to do the track with. The top right, the black color, is good aggregate. Everything else is different degrees of not good. So we had huge problems in recommending that that barge of aggregate from Palau was good enough to do the resurface work. We started to look at the local quarries in East Lombok. Now, they are small quarries. They would never be considered to supply aggregate to a racetrack in Europe, for example. They're small, little local quarries. And a lot of those can't see in the photographs, but the shape was really bad, the aggregate was really dusty, it wasn't the correct size, lots of problems. This is us in our villa, looking at aggregates from different quarries in Lombok, trying to decide which is good, which is bad. And if you remember, this was done just a few weeks before MotoGP. There was huge pressure because this was the project in Indonesia for the president. This was the president's project. So we had huge pressure in trying to get this work done. We basically started to do a lot of training for people involved in the project. We wanted to know that they knew what they were doing or what they were expected to do. Just what one of the directors said this morning. People need to know what they're doing. So we're just basically training, making sure people know how to do something as simple as sample a stockpile. We had briefing sessions. These might sound really simple. And what's this got to do with smart and green technology? But if the people who are doing the work don't understand and don't know what they're doing or the significance of what they're doing, and one of the key things that we were telling these guys, these are the guys who work the machines. These aren't the managers, these are the workers. If these guys see a problem during their work, they tell us immediately. And they stop the problem from getting bigger and bigger. And this is why we find this type of training really, really important. That everyone knows why and what they're doing. We worked with the guys in the lab. It was a site lab, very, very basic. This would never be allowed in a European track, for example. But Lombok, it's an island, and the guys here in the lab were really good. They're very, very good technicians, very good with materials. I think we did maybe 5 or 6 Marshall mix designs on the different sources. If anyone knows the work that's involved in that, that is a lot of work to do in a site lab like that, under those conditions. We could not get or bring in the big mobile asphalt plant again, so we had to work with the 2 local asphalt plants. One of them had never made SMA before. You can't see in the photograph, but it was quite a, let's say, not what you would expect asphalt to be made in for a racetrack. We wanted to know, could it make asphalt? So we did lots of trial mixes. We brought in 3 pavers. 2 of them worked together on echelon to reduce or to avoid a joint down the middle of the track. We had to know, were they good enough? Could they lay the appropriate tolerances? We started to mill out the track before we started to make asphalt. It was a huge gamble. If we could not make asphalt, the track was ruined. It was not fit to be raced on by MotoGP. But we had to make the decision to start to mill out because of the very short time period we had. We had never made SMA from the sources before, so we had to make a trial. And this is the first trial mix. I say SMA was never made from this material before. We wanted to know what the densities were like, the void contents were like. We wanted to know, would the machine and rollers make it flat? What sort of texture would we get? These are all the requirements from MotoGP. And say we didn't know if we could make SMA to meet the requirements of MotoGP. The first trial contained the aggregate from Palau, the material which we said was not good enough. And one day after we led the first trial, the Palau aggregate was starting to fail. After one day, and this is the same aggregate that failed in the main track. So we had to use Lombok aggregate. Second trial, we had to see could the two machines work together and lay on echelon to achieve full width of the track. So we had to see were the screeds right. We had to just basically see did the machines work. The photograph here in the right side, there is some smoke. That is the smoke coming from Rara, because the track here was wet during the trial, and Rara was burning and telling the rain to go away, and it worked. It worked. I have a lot of respect for Rara. Okay, so as I said, two machines, big extensions. Those screeds cannot flex. They have to be totally rigid, because if they start to flex, particularly going around corners, the track will not reach the tolerances that we're asking for. We had to know that the rollers could work together to get all the bumps out. So this second trial was really, really important before we went on to the track. We checked out the second asphalt plant that was a bit newer. Again, would not be of the standard that you would expect to supply a racetrack in Europe. But again, we were working on trial mixes here just to see could it make SMA. This is the cellulose fiber, the via top, which went into the mix. So we milled off the surface, the top 50 millimeters down into the top of the binder to get rid of all of the SMA. The top of the binder was dirty, so we had a lot of problems in actually cleaning the dirt and dust that was created during the milling process. So we brought in the local fire people from the airport to physically wash the dirt off the track. We then put down a bond coat, polymer modified bond coat, and the guy on the left is actually painting the edges, so the edges have got good seal and don't let water into the lower layers. So everything ready to start. A lot of work in every one of those stages, making sure that everything is going to work. We had an SMA mix that would work. We had pavers that would lay to the tolerances that we expected. Rollers that could get a flat surface, texture, compaction, voids, everything was done on a trial, and then we were ready to start the laying process. Getting the machines onto the track is a problem because you don't want to contaminate or damage the existing surface. Because the asphalt plants had never made SMA before, certainly in large volumes, we had a lot of problems with big lumps of SMA in the back of the lorry, going through the paver, and then creating problems on the new material that was going to be compacted. Then sort of the key to success to a racetrack, and any road that you want it to be flat, is that you have to work with the rollers to get them flat. If you just say, we'll keep rolling, you can over-compact your material. So there's an optimum somewhere between compaction and flatness and density and texture that you need for skid resistance. End of first day, everybody was tired. It was a very stressful day. We didn't know whether it was going to work or not. Remember, the president was expecting MotoGP race to happen 2 weeks after this work was finished. A lot of pressure. Even guys, they get finished, but the guys who are doing the compaction, and particularly trying to see that it was flat, they worked well into the night to make sure that everything was flat. Day 2, we just started again, and we just kept going, and going, and going, and we got finished. Okay. Last slide, one more slide. Okay, next slide. Yes. Yeah. Rara helped us the whole way. I have to congratulate Rara. Without her help, during this stage of the work, we needed good weather. We had 5 days to do this work, 5 days. If it was wet for 2 days, we would not have got completed. And MotoGP would have said, no race. That's the pressure that we were on to do this work. MotoGP, they were going to say, no race, if this work was not done within 5 days. And then your president would not have been happy. Okay, but we have to thank and acknowledge Rara for this work. So, a case study, lessons learned. I've been working with SMA for maybe 30 years. In the UK, we've taken SMA, we've developed many different hybrid versions of SMA. The SMA at Mandalika was a simple SMA, but it failed within 3 months and got progressively worse. And this case study showed how we went in and we fixed the problem and had the race ready for MotoGP. The key thing was, the really annoying thing was that the surface that had been made at Mandalika was very good. It was a very good surface. During the summer of 2021, the people involved, all the testing, everything had indicated that it was a very good surface. It was totally flat. There were no bumps. The texture was really good and uniform. It was a perfect race circuit for MotoGP. However, it failed. So to conclude, for SMA to work, as I said at the start, it is simple to make, but it's simple to go wrong. And I've used this case study to illustrate different ideas, different things that we did during the resurfacing to illustrate what needs to be checked and confirmed before you go down the route of SMA. And then once you understand that, you've got many, many different possibilities with SMA to make it smart and to make it green. And I think I sort of agree with what I think the rector said this morning. People need to do, or people must know what they're doing, because nobody recognized the problem during its construction. Okay, thanks very much.
Thanks, David. One thing that I really love from David Woodward is his Irish accent. It brings me to the time 25 years ago when I was there, and every day I heard something like this one. An Irish accent is very nice. If you want to learn English, please refer to Irish accent. It's very clear, not too fast and not too slow. I just promote Northern Ireland. Okay, there are so many lesson we got from David Woodward. I tell you the truth, David. You are talking about the Palu aggregate, but as far as we know, right now in Indonesia, Palu is a good aggregate. So now you have to change your mind, right?
No, I disagree with that.
Yeah, sorry, I just tell to the participant, just put in your mind, Palu is not always a good aggregate, right? You have to test it, you have to control it, everything. Don't just accept that this aggregate is transported from Palu and it is a good aggregate. No, just put your eyes and just control that. Okay, David, please. You want to add something?
Yeah, I don't want to say that Palau is a bad aggregate. Palau is a very good aggregate. We got samples sent back to the UK, and in all the tests that we did, it was very good. It's just that at the track, we had the failure. After everything was suggesting that we were going to have a very good circuit, we had this unexpected failure. And the failure which I've described is not unique to Mandalika. This is a problem around the world. It's a problem back in my country, in the UK. And as Siegfried says, do not just accept an aggregate. You have to test it. And one of the problems, I think, is that people relied on the Los Angeles test for Mandalika and nothing else. And the type of failure that we had would not be picked up by Los Angeles. It's a durability failure, it's a soundness problem. It's something which is maybe influenced by the high temperatures that we had to mix the SMA at. There's many different reasons, but certainly I am not saying Palau is a bad aggregate because it is a good aggregate. It's just Mandalika, we had problems.
This everything just test it before you accept it. Okay, this is very nice. I just can imagine how big pressure you got when you prepare everything in Mandalika. You mentioned 3rd of March you just started work, and 24 March the Superbike should be started, right? So how big pressure you got? This also that even we are a civil engineer, we also got some pressure when we are working, right? This is the main problem. Not just relax. We have a consultant, we have a contractor. We are the also that government officer. Okay, that's very nice. Alhamdulillah, thanks God. The Mandalika first racing was very success, and I don't know, you still have a big problem when prepare for the second racing next year or this year.
Yeah, this is the World Superbikes will be back in November, and MotoGP are due to be back in March of next year.
Okay, relax, Pak. So we have a question time for 30 minutes. I invite 3 questions from my right hand side. Please raise your hand up.
Excuse me, Ms. Siegfried. Siegfried?
Yes.
Excuse me. I just want to talk to the audience first. We already prepared the coffee break behind the area, so you can enjoy the coffee break while during the question and answer section.
Okay, yeah. Okay, please, if you want to have a cup of coffee. Okay, please, from my right hand side, 1, my right hand, 2. Okay, from my right hand side, preference right. The man in the brown dress, please ask a question and mention your name, your affiliation, and who your question is addressed to. Please. Silakan, Mbak. Silakan.
Okay, thank you, sir. Test. Okay, I want to introduce myself. My name is Bugimon. I'm from Universitas 17 Agustus Samarinda. So I want to question with my Prof. Sakti Aji Sasmita. Prof, I want to question about what is different mega airport with smart airport. Maybe you can give me different with mega airport and smart airport. And then question two, I am interested about circular airport. How about reduction centrifugal force when airplane landed in circular airport? Maybe you can give me penjelasan. Thank you, sir.
Okay, the next one for my right hand side. Okay, Pak.
Assalamualaikum warahmatullahi wabarakatuh. I introduce my name, Andi Marewangan. I am from Bro Regency, head of the transportation department. Mr. David, welcome to Balikpapan. I am interested with your presentation. Your surface with the SMA 10. This is, I think, very important for the circulation. But I don't see about your reason about base, sub-base, about the structure asphalt system in the Mandalika. Why you don't presentation this? I think this is about the problem. This is just surfaces, but I think BAM and the problem in the surface asphalt, I think base is important too. Thank you.
Okay, two questions for this conversation. The first one from Pak Kusina Universitas 17 Agustus. What is the differences between mega and smart airport? And second one, how much the reduction for circular force centrifugal, something like that one, right? For circular airport is very nice. He is a really a researcher, you know. He consider about the centrifugal force for the circular airport, but just remember that the radius is quite big, right? Okay, the second one from Pak Andi Biro City. Why don't Miss David didn't show about the subgrade, the foundation, the aggregate class A or class B or something like that one? Okay, this is really nice question. But as far as I know, David has done many research on subgrade, also for the aggregate foundation layer. But it's okay. It's okay. Later he will explain about that one to you, Pak Andi. Okay, first, please, Prof. Sakti, answer the question from your student. Okay, thank you.
Pak Tukimun, he is my doctorate student. He already done his doctorate program. I will answer only important point. This time you ask me question. Last time I asked you many questions, changing situation. The first is a mega city and mega airport not different. Each concept is supporting each other. So mega airport is a large airport need to implement need space of land, a big land, and then should be supported by smart airport because right now we develop smart airport and then supporting also intelligent transport system. So the concept of airport city, aerotropolis airport, mega airport should be supported by smart airport, make airport become operational effectively and efficiently, sustainable. And then for the second question about the centrifugal, if we know if the reference said that the diameter of circular airport is the diameter is 3 kilometers, so quite big large space. And then if the diameter is 3 kilometers, it's likely airport is not looks like a flat airport because the diameter is 3 kilometers. So it's quite large space of land. Is it possible to implement it? Maybe in 2050, maybe will be implemented. Because we have to think futuristic in long-term period. Kita harus bermimpi. Kadang mimpi jadi kenyataan, ya. Jadi tidak hanya bermimpi tentang konsep airport yang futuristik ke depan, sama dengan kalau kita membayangkan pacar, ya, berarti kita harus implementasi nanti. Kita harus mendapatkannya sama dengan futuristic airport. Kita harus bermimpi dan become reality. Ya.
Okay, thank you, Prof. Sakti. So, in other words, for the big diameter, the centrifugal force can be negative, right? Okay, flat or something. Okay, David, someone asked you about the foundation and subgrade in Mandalika, but I know you know much more about the foundation and foundation layer and subgrade layer. Please, your time.
Okay, thank you for the question. The answer is very simple. Why I didn't talk about it is because I was invited to talk about SMA. And in Mandalika, the SMA was just in the top layer. But I say, we had an interest in all of the asphalt layers, but we had no involvement with the lower stone layers, sub-bases and subgrades and whatnot. But obviously I was out, I saw the construction in January 2020. I saw how they'd sort of dug out the track through the different types of soils and whatnot that was present on site. I saw the materials that were starting to be brought in, so I have some ideas and whatnot. But certainly, irrespective of the subgrade, the subbase, the lower asphalt layers, The problems that I described at Mandalika would have happened irrespective of any problem lower down. The aggregate failed by sitting in the sun and by heating up in the temperatures and getting wet every time it rained. It failed without any traffic. And that is the key thing to think about when you're thinking about aggregates. I've traveled around Indonesia a lot over the years. I have seen many different roads, lots of road trials and whatnot. And one of the things that I'm interested as a geologist is the aggregate that is used. I can look at a road, I know what the rock type is, I know its properties, I know how it's going to fail. And as soon as I saw the first photograph from Mandalika, I knew the problem. But it was only until that layer of bitumen was exposed to expose the aggregate particle underneath that no one saw during the works during the summer. Everyone thought the track was going to be good. And it was a real surprise to basically everybody when I started to explain what was going to happen step by step by step, and every prediction that I made leading up to Superbikes, then after Superbikes, and then leading up to MotoGP, everything that I predicted that was going to happen, happened. And the latest story, I don't know whether you know this or not, but the entire surface of Mandalika is going to be resurfaced over the summer because it's totally shot. And that is down to the weathered aggregate. And I say that is not smart, that is not sustainable, that is not green. That is just a very unfortunate problem that nobody at the time picked up. I was in the UK, I could not get to Lombok because of COVID. And if I'd been there, I may have identified the problem and said, hold on guys, we have a major problem at Mandalika here. But because of COVID, everything had been done. The track had sat there for 3 months and was failing. And again, I think this is an issue that's happening around Indonesia. A lot of the roads that I see have got some very good aggregate and then smaller amounts of not good aggregate. And it's the not good aggregate which I think has been the problem for the SMA failures in the past. I need to talk to Siegfried more about the failures and anyone else who was involved in those projects. But certainly, from what I described, the work that we did earlier this year, if you take it step by step by step and understand everything, you can reduce the risk of a problem, of a failure. And I said, SMA is easy to make. It's also easy to go wrong. But it is such a good material. It is perfect for the title of this conference, Smart and Green. In my view, SMA and how you can develop SMA through all the different hybrid versions, that is the future in road construction. And certainly we have done that development work in the UK, and we have a lot of experience in achieving these goals that you're trying to set out in Indonesia.
Yes, thanks, David. One lesson we can get from this the discussion is that dealing with the aggregate is not easy. Fulfill the spec or not just simple as that. So it's we have to be much. Okay. So we can say that aggregate is not so easy. It is just it is not just a matter of price or sources or something like that. There are so many knowledge behind an aggregate, the aggregates. Okay, yeah. Okay, I invite from my left side. First, Pak Luki and okay. Oh, sorry. Okay. Oh, one question. Okay. One, Pak Luki. Second, Vera, please. And the third from Prof. Sakti. For the other one, we can give an extra session in the third section. Okay, Pak Luki, please. And Vera, please prepare your question. And Prof. Sakti, please prepare your question. Oh, it's okay.
Thank you. My question goes to the second speaker, for Mr. David. What is your opinion on SMA application of Indonesian public road with the influence of the Indonesian weather and climate? Thank you.
Vera, he is my neighbor in Ujung Berung, Bandung. His father is my close friend. I think she's she's a lecturer from Bandung Polytechnic.
Okay, thank you, Mr. Sifred, for your opportunity. I am Atmi Farani from Polytechnic Negeri Bandung and ITB. I want to ask to second present Dr. Mr. David. I want to ask about stone mastic asphalt that I'm working on while in my research. The stone mastic asphalt that I'm working on is designed based on specification for coarse aggregate for low traffic using a pen 60 of binder asphalt. It's just that after testing with the Marshall's test, the VMA and flow it always doesn't fit into the specification, even though the asphalt content is used quite high. My question is it really that difficult to make a mixture of SMA? And then what should be done to produce the good stone mastic asphalt? And does the asphalt binder penetration is matter? And for your information, when I testing the Marshall, the sample is using paraffin first. Thank you.
From the other keynote speaker.
Hey, relax. I want to ask Pak David a joke question. You mentioned many times about Rara. I asked a joke question: is there any influence Rara in this project?
Okay, this is quite interesting because I personally have two friends involved in Mandalika project. Even I've never been there. One is David. David is my quite close to me. The other one is Soheli. Soheli is a site engineer who's working in Mandalika. So I always get update news from Mandalika. Okay, but one friend of mine asked a quite strange question. How about Rara? Cloud engineers. Okay, David, this is very nice. The first one, I just want to say to ask again: is there any possibility to apply SMA in Indonesia, right, Paruki? Okay.
Okay. Okay, well, I'll start off with the joke question about Rara. Rara is not a joke. She was sent to Mandalika by the president. That is how serious that work was. The president sent Rara to Mandalika. And we worked with Rara. Okay, you can smile, whatever, but let's say, for the construction which I talked about, we needed 5 dry days. We had a very, very short time schedule. And as I said, if it rained, we would not get the work finished. No race. And please do not believe the internet. Please do not believe the internet. They say all sorts of things and they go up all sorts of stories. They do not know what is actually happening. Okay? In terms of Mandalika, they were just speculating. They were just making up ideas. All I'm saying is we needed 5 days. We had 4.5 dry days in the wet season in Lombok. Okay, and she was there. And then during MotoGP, for other problems which I haven't talked about today, we needed the circuit to be wet because the temperatures of the asphalt were extremely high. It was the highest that MotoGP had ever experienced in any circuit around the world. And we needed the track to be wet. So she came and we had wet racing. Okay, and so from one extreme, good weather to bad weather, she had a part to play. Okay, because the temperatures were so hot, nearly 70 degrees centigrade. And at those temperatures, a polymer modified bitumen just doesn't work. It's too hot. So, will SMA, or does it have a future in Indonesia? It definitely does. Yes, it does. Once you understand SMA properly, let's say, as I said at the start, it's simple to make, it's simple to go wrong. You have to, again, this is, in the UK, we've been working with SMA for about 30 years now. And at the start, we had a lot of problems because we followed the specifications. We followed the standards, okay? And it is very, very competitive industry in the UK. There are a lot of big companies, very, very specialist knowledge, and they did a lot of development work with SMA. They had big failures at the start, okay? And they stopped, and they said, why are we having failures? Okay? And they started to think about SMA in the UK environment, the climate, the aggregates, the bitumens, the asphalt plants, the equipment that we use to construct roads. We then said, okay, how can we make SMA better? Can we improve its skid resistance? Can we improve its noise? Can we make it more resistant to heavy vehicles? And I know heavy vehicles in Indonesia is a huge problem. And we developed SMA into all of these specialist products. And that process, it's a lot of laboratory work, non-standard laboratory work. And then we put road trials down, we monitor the trials, and after 2 years of the trial, we say yes, we give it a certificate, and we say, okay, that SMA is quiet. We use that SMA in a city. That SMA has got good skid resistance. We use it for high-speed traffic. That SMA has got really good resistance to heavy vehicles. Okay, we use it in the slow lane of a toll road, or we use it in the slow lane, get into a port where we've got a lot of heavy traffic moving slowly, because the materials that we use in the UK, particularly asphalt concrete, doesn't work. And then when we bring in climate change, and we start to talk about warmer temperatures, and we're talking about colder temperatures, All it takes is a few days of really warm weather and our road network is gone. It's rotted, it's deformed, and it's a massive amount of money to fix it. And I say SMA, because of its properties, is one way to ensure against future climate change problems, as well as making something green and sustainable. So I think SMA and developing it further beyond the standard specification, that is the future for Indonesia. You have to consider the aggregates, you have to think of the climate, you have to think about the traffic, you have to think about the location. Lombok Island is not the place to build a MotoGP circuit. As we discovered, there were many, many problems, but it is a fantastic location. Mandalika is a fantastic circuit. I've been around a lot of circuits, and I think it's a really good one. It's up near the top of circuits for motorsport. Yeah, well, I say sort of there's a basic specification, there's Marshall, there's other ways of designing SMA. I think maybe we'll have a chat afterwards. I've been really interested in hear what you've been doing and what you're finding out, and if there's some way I can maybe help you in some way, we can talk later.
Okay, Vera can discuss later when we have. I mean, if serious discussion is always after lunch, right? Okay, we just have 10 minutes left. The other question from the gentleman in the back.
Mr. Siegfried?
Yeah.
There's a question in a Zoom section, yeah. Would you want to
I have
read
to
it?
stand here, right?
What is? It's from Reni Octaviani Tari. What is the ideal temperature of high school asphalt in the tropical region, and how much penetration is used?
It's a very funny question. High school in Indonesia is a sekolah menengah atas, SMA. So she asked, what is the ideal temperature of high school asphalt? I have to say, I
think she's using Google Translate, I think.
SMU mix.
SMA.
It's really funny.
She's using translator.
Later on, Pak Luki will do research about SD asphalt mix and university asphalt. Okay, what is the ideal temperature of SMA in the tropical region, and how much penetration is used? Penetration is a classification, not how much penetration is used. We never use this parameter anymore in this. Okay, just David, this quite a good question for pre-university mix.
I don't know. All I can talk about is from Mandalika, and I think we recorded 68 degrees centigrade on the circuit just before or during MotoGP. 68 is by far the highest of any circuit around the world. We were in. I was working in Miami, Formula One, last month. We were involved in the circuit there, and in Miami in Florida, we had air temperatures 30 degrees centigrade, and we were only getting sort of track surface temperatures of about mid-40s, low 50s. So I think the extreme temperatures that we got in MotoGP was because the surface was so new. It had only been laid a few days before it was handed over to MotoGP. It was black. Pure black. overhead sun that just absorb the heat. And whereas if you think of an older track that's maybe gray, it's absorbing less temperature, and so those temperatures are not as great. Maybe that's something to think about in the future. If you are going to develop SMAs here, is there color? That could be down to the aggregate, and certainly there's a lot of work done in America where they make gray, reduce the black and make it gray, and that's all to do with the temperature that they'll get. Okay, so certainly here it's air temperature is pretty constant. It's what air temperature is in 30s, mid-30s all year round. So the road surface temperature should be fairly constant, but Mandalika was extreme. And I think it was because it was so black with being so new.
Yes, thank you, David. It's very very good answer, because the color of the asphalt surface would also affect the absorb of temperature, right? Okay. So, Pak Luki, please note the color of asphalt surface would be would affect the absorption of temperature. Okay, the last question from the guys in the back. Oh, he is in coffee break, right? There is no more question. Last question, Prof. Izzy, no question. Actually, I also have the same question about the PNB from Jakarta. I just want to know what factory, where is it? As far as I know, is Carnival from Shell, right? But you mentioned about Jakarta. There's no plan of Shell in Jakarta. Okay, thank you. Prof. Izzy, I don't know, maybe we discuss it in personal discussion, right? We can open it in public, something like this one, okay? Right? Okay, this is really secret. Okay, West Java. Yes, I know. Also, the guys, I know him, but we can discuss personally, right? Okay, there is no more question. So I want to be back to MC Bu Raisa. Please, before that, I also I have some notes here. Some notes here. The first one is SMA is really good for our surface, pavement surface. Yeah. The second one, mega city, mega airport is one of our dream. Hopefully in next 20 and 30 years time, it will be a reality.
But secret,
yeah,
I quite sad because no one participant asked me about the human resources in airport, especially air crew, especially pramugari.
Yes. We can discuss it personally, Prof. Okay, I went back to Bu Raisa, please, Bu.
Okay, thank you, Mr. Secret, Mr. David, and Mr. Sri. Give an applause, a big applause for the keynote speakers and the moderator for today. Okay. Give it back to your seat, please. Okay, first of all, before you back into your seat, let us take your picture together. You can stand in the middle of. We're gonna take a picture of yours. Okay, we're gonna take the other picture. I'm gonna look back. Yeah. So the audience is the background. Please, to the audience, can you stand up? Because we will take a picture of you, all of you. Please stand up. Okay, all of the audience can stand up because we were gonna take a picture of you, all of you. Or you can move forward so we can take. Okay, thank you. Okay, ladies and gentlemen, we're going to move into the second section from the second keynote speaker. To those of you who are still taking a coffee break, come back into the seat. Okay, ladies and gentlemen, we will go next to the keynote speaker number 3. So all of audience can back into your seat, and we'll begin our second speak. Now I'll introduce our moderator who will guiding the conference. Please warm welcome for Sri Atmaja, PhD. Mr. Sri is Director of Graduate School of Universitas Muhammadiyah, Yogyakarta. Good day, Mr. Sri. Mr. Sri, the conference is in your command now. We will give you 20 minutes for presentation and explanation, and 30 minutes for question and answer. The time is yours.
Thank you, Pak Desa. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Now we reach second session of the keynotes, and my name is Sri Atmaja, it's already introduced before. And I would like to invite the second keynote. Please come here. Professor Izzy. In these occasions, I would like to introduce Professor Izzy. It's okay? Technically okay? Okay, great. Let me introduce Professor Izzy. He's my colleague, he's my friend, my close friend. from Malaysia. He received his bachelor's from UTM, University Technology Malaysia in 2005, and continued his Master of Engineering in 2005. I mean in Bachelor in 2002, right? I'm sorry. And he received a PhD degree from the University of Nottingham, UK in 2012. Now he's a Vice President for Transportation Science Society of Malaysia, and he also a member from other professional bodies like a Board of Engineers Malaysia, Road Engineers Association of Malaysia, Road Engineers Association of Asia and Australia, and also he member of the Association of Asphalt Paving Technologies. His research topic or research interest in the pavement materials, design and construction, rehabilitation, and also road safety. Dr. Nur Izzi is very active academics, already published more than 185 technical papers in the pavement engineering in the reputable, international reputable journals. And also he already produced more than 80 road safety reports, 35 articles in magazine and newspapers. He's also active to supervise more than 30 postgraduate students, and also serve as a reviewer in the international reputable journal. In this note is already 400 papers already reviewed by Dr. Izzi. So now we invite him to present the topic of sustainable and innovation asphalt technology. We have 20 minutes and more, and continued by QA. Dr. Izzi, the time is yours.
Bismillah, alhamdulillah, assalamualaikum warahmatullahi wabarakatuh, and very good morning. Bapak-bapak, ibu-ibu yang saya hormati dan dirahmati Allah Subhanahu wa taala sekalian. Terima kasih, pertamanya terima kasih kepada Prof. Sri Atmaja daripada Universitas Muhammadiyah Jakarta, dan juga para Profesor Bakti, Profesor David, ibu-ibu dan bapak-bapak sekalian lah. Ya, so hari ini tajuk saya agak umum sedikit lah. Saya tadi kita sudah ada tajuk yang quite specific. So for this one, I'm going to talk, more general topic lah, entitled on the sustainable and innovative asphalt technology. Hopefully, I can finish within 20 minutes, yeah, inshallah. Okay, first we go. Next. First, we go for this some historical background. From this figure, we can see that the pavement structures decreased from about 900 millimeter to 1,000 millimeter for Greek or Roman design to 350 to 450 millimeter for Telford design, and then it goes down again to 250 millimeter for macadam design, and then to 140 to 150 millimeter at least 1800s or early 1900s. But after that, we can see because of an increase in pavement, pavement thickness. This is due to the presence of heavy load and high traffic. So this one we are talking about the current flexible pavement. Actually, for this talk, I just focus on the top layer, which is the flexible pavement. I know that in Indonesia now we are very active of constructing the rigid or concrete road, but for this talk, I just focus on the flexible pavement only. Yeah? And then we can see towards the end of the last bar, we got another types of flexible pavement known as the long life asphalt pavement or perpetual asphalt pavement. This one, the thickness is around 300 to 750 millimeter. So, but we're going to talk about this towards the end of the presentation. Next, okay. Next, we have another history still in the bagian sejarah. Bagian sejarah. This is the, some background of the road history. Actually, I took this photo. Sebenarnya foto ini diberikan oleh Professor Nikolaides. I think Professor David knows about this. Professor Nikolaides from Greece. Actually, he's also the author of the Highway Engineering, Pavements, Material and Control of Quality textbook, where he did mention that the earliest road was found in northern Greece in 424 before century. This urban road is approximately around 4 meters wide. Next one we have, I think everybody knows about this, the Via Appia or the Appian Way is one of the earliest and strategically most important Roman roads of the ancient republic. It connected Rome to Brindisi in South Italy in 312 before century. The main goal back then was to move troops more quickly during the Second Samnite War, but also to facilitate day-to-day transport of goods between Rome and Campania. The width of the road is approximately around 3 meters in rural areas and 5 meters in near cities. Next. Next, still we are in the history. Kita ada jalan Via Egnatia was a road constructed by the Romans in 130 before century. It crossed Illyricum, Macedonia, and Thracia, running through territory that is now part of the modern Albania, North Macedonia, Greece, and European Turkey as a continuation of the Via Appia. Like other major roads, it was about 3 meters wide for the rural areas and another 5 meters wide near to the cities or urban area. Next. So this is just example that I want to show the highways in Malaysia, these modern roads in Malaysia. We have around a total of more than 2,300 kilometers for the highway. But if I'm talking about the paved road in Malaysia, we have around 183,000 kilometers for the paved road. That is the total of the roads, 180,000 kilometers, 143,000 kilometers are paved road, 26,000 kilometers are gravel roads, and for another 14,000 kilometers are earth road. But if I were to compare, bila Prof Sakti bagi tahu dekat Indonesia we got saya ingatkan 17, rupanya 17,000 islands. So I raise my case lah. Saya tak boleh nak compare dengan Indonesia. But this one just case for the Malaysia. Okay, so I think this one we just we go for the next one. I think just to revisit the meaning of the sustainable. So sustainable development is the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So the term sustainable in the context of pavement can be referred to a system that encompasses pavement ability to, first is to achieve the engineering goals for which it was constructed. Second is to preserve and ideally restore surrounding ecosystems. Third is to use financial, human, and environmental resources economically. And the last one is to meet basic human needs such as health, safety, equity, employment, comfort, and happiness. So this one is the definition of sustainable pavements in the context of environment. Actually, this the definition was given by Professor Miller and Professor Hussein Bahia from United States, whereas a pavement that minimizes environmental impacts through the reduction of energy consumption, natural resources and associated emissions while meeting all performances, conditions, and standards. Next. So this one again, we just revisit. I think everybody knows about this, what goes into the making of asphalt. The first one, we have the aggregates. Aggregate used in pavement construction can be natural aggregates from natural deposits. I think in most cases, in Malaysia and also in Indonesia, we are using gravel. We use gravel aggregates, and then maybe in some certain area we are using the limestone aggregate as well. So we also have the crush aggregates that produce in quarries, and then we have slags. Slags is a byproduct of steel, copper, or tin. I got experience before we did some research doing the steel slag. The performance of the steel slag is as good as the crush aggregate, but the problem is kita perlukan lebih banyak bitumen because of it has pore, dia ada liang. So that's why more bitumen is needed when we use this slag aggregate. And then we have the mine waste. Mine waste is a rock with low metal content rejected during the enrichment process. We have the demolition materials, artificial aggregates such as calcium oxide has a good anti-skid properties, recycled materials and other materials which meet the required mechanical, natural, and chemical properties for the layer to be used. But I think here the most important thing is for us to comply of properties of aggregate materials with nationally limit value set is a must and undeniable. So this is the most important thing. Next. So this is some tips for improving sustainability from aggregate materials point of view. The first one is to use crushed aggregates instead of uncrushed aggregates for unbound or hydraulically bound mixers. The second one is to use only crushed, clean, and resistant to fragmentation aggregates for asphalt mixtures. Third is for surface coarse asphalt mixers, you use only crushed, clean, and resistant to polishing or abruption aggregates. So limestones are not suitable, but this one, when I had a discussion before with Professor Halil Chelam from Iowa State University, where he did mention that in US, when they use the limestone, the performance is as good as the gravel. So maybe this one is, we have to go in detail about this. Of course, we are talking about the resistance to polishing and abrasion. We got the expert here, Professor David Woodward. So next one is to minimize the transportation costs, reduce the amount of virgin aggregate use. So this one, we are promoting to use the recycled material, build pavement on subgrade with adequate bearing capacity, if required, provide capping layer, or use stabilization techniques such as cement, lime stabilization, or also use the chemical stabilization agent. I think Dr. Marina is expert in the soil stabilization. Yeah. Next. So next one, we have the second material, which is bitumen or asphalt binder. Actually, bitumen and asphalt binder are the same thing. Whereas the bitumen is normally used by the UK or European researchers, and then the asphalt binder is used by the North American researchers. They are the same, the black sticky material. So we have different types of this bitumen that we can use. The first one, we have this paving grade bitumen, which is used in Europe and UK. Also, I think used in Malaysia and also in Indonesia, or performance grade asphalt binder. This one is used in US during the super pave time, superior performing asphalt pavement. So when you come across with the term PG, for example, PG 76 minus 28, so that one's belong to the performance grade asphalt binder. Prof. David, if I tell something wrong, please let me know. And then we have another types of bitumen, hard pavement grade bitumen, oxidized bitumen, modified bitumen, special bitumen, bitumen emulsion, and also the cut bed bitumen. Various types of bitumens can be used for the construction. Just I want to share a bit with all of you about this Malaysian specification. In Malaysia, we have 3 types of bitumen or asphalt binder that we use for the road construction. The first one, we have the 80-100 penetration grade bitumen. The second one is 60-70 penetration grade bitumen, which is, I believe that in Indonesia, we're also using the same 60-70 penetration grade bitumen, also in Singapore and also in Thailand. And then the next one we have, nowadays in Malaysia, we didn't use 80-100 anymore because of the weather and then increase of the traffic volume. We started from May 2017, we already shifted to 60-70. This one is for the conventional. And the next one, we have this PG76, performance grade 76. Of course, in Malaysia and Indonesia, we are the same. We just have a very high temperature, but we don't have the minus temperature. That's why we have PG76. So, but this one, I believe that PG76 is the polymer modified bitumen. Next. Okay, the next one we have the modified bitumens. Modified bitumens are bitumen whose rheological properties have been modified during manufacture by the use of one or more chemical agents or modifiers. The modification alters and improves certain bitumen properties, which result in improvement of the respective bituminous mixture or application and therefore improve construction quality. Examples, we have many examples here of these modifiers. We call as the modifiers. The first one is the polymer. Polymers such as 2 types. Normally, this is the most well-known ones. We use the elastomer and plastomer. The most well-known elastomer used is the SBS, styrene, butadiene, styrene, or SEBS, styrene. I can't remember, SEBS or styrene, butadiene, rubber, SPR. And then we also have this plastic type of polymers. And then I think the current research also, we are looking into the recycled polymer, like waste plastic, so on and so forth. It's quite interesting these days. And then we have these chemical modifiers. We have fillers, fiber, hydrocarbons. And then I add another 2 materials here, which is quite interesting. Nanomaterials, we have different types of nanomaterials, such as nanoclay, nanosilica, nanoalumina, and etc. This is quite interesting as well, because when I read a paper from Delft University, I can't remember this professor's name, and then they found that the use of nanoclay can improve the properties of the asphalt mixtures. And then currently also riset yang agak popular sekarang adalah penggunaan biobinders ataupun bio oil. So bio oil can be used as the modifier, it can be used as the extender, and also can be used as the replacement. And then in terms of the improvement, this one depending on the modifier used, there resulted improvements to the bitumen. So banyaklah perkara yang kita boleh ubah. Tetapi akhirnya kalau dalam pengajian pavement ini, at the end of the day, what we try is we try to overcome the rutting problem at high temperature. This is the first one, rutting at high temperature. Second one is we try to overcome the fatigue problem at the intermediate temperature. I think masalah ini berlaku dekat Malaysia dan juga dekat Indonesia lah, fatigue problem. The last one we are talking about the cracking at low temperature. Tapi untuk yang low tu mungkin tidak sesuai lah dengan keadaan kita. Special bitumens. Special bitumens are bitumens manufactured by process and from feedstock chosen to confer special properties that meet stringent requirements for paving and industrial application. Kat sini pun banyaklah kita ada pelbagai jenis special bitumen. Yang pertama adalah multi-grade bitumen. Second one is a fuel resistant bitumen. Third one is a color or pigmentable bitumens, macam yang Prof David bagi tahu tadi lah, macam mana to reduce the pavement temperature is to use the color or pigmentable bitumen. Tapi masalah bila penggunaan color bitumen ini dia high cost, and then pavement surface gets quickly dirty, dia cepat kotor lah. And then satu lagi kita ada bitumen for joint and crack filling. Next. This is some tips for improving sustainability from bituminous binders point of view. The first one is use the appropriate type of bitumen for the production of asphalt mixtures. This one we should consider traffic and environmental temperatures. And then again use polymer modified bitumen with thermoplastic elastomer. Ini paling banyaklah digunakan dalam pasaran. Polymer modified bitumen menggunakan elastomeric type of polymer in asphalt mixture for the surface. Use only bitumen emulsions in tack coating or prime coating. Never use cutbacks of flux bitumen. Ini ada beza lah kalau kita gunakan bitumen emulsion dengan cutbacks. Dia ada beberapa sebab, contohnya segi alam sekitar, waste of resources, sebab emulsion ni water based, jadi dia lebih environmental friendly lah as compared to other types of binder. The next one kita ada to minimize the transportation cost, and then also kita try to minimize the storage duration of hot bitumen. Ini untuk kita mengelakkan berlakunya aging, to avoid the occurrence of the aging. Okay. Next one we have asphalt. Asphalt, or in Europe it is known as asphalt, but in US it is known as the hot mix asphalt (HMA). So kita ada banyak jenis dekat sini. Ini secara ringkas lah. Saya beritahu yang pertama kita ada asphalt concrete or dense coated asphalt mixture. Yang ini yang jalan biasa lah. I think most of the roads are paved using this type of asphalt concrete. Yang kita gunakan bitumen 60-70 tadi. The next one kita ada juga teknologi asphalt concrete for thin ACTL, which is around 30 to 40 cm, or asphalt concrete for very thin layers. This one is dalam 20 hingga 30 mm. And then kita ada satu lagi teknologi tadi yang telah discuss in greater details by Professor David, stone mastic asphalt, juga dikenali sebagai stone matrix asphalt, but still we are using SMA lah abbreviation there. And then we have this UTLAC, ultra thin layer asphalt concrete, which is very thin, around 10 to 20 mm. And then jenis lain lagi porous asphalt PA ataupun open graded asphalt OGA. And then this one, porous asphalt, is quite famous in Europe lah, especially like in Dev. And then the next one we have this. Kalau yang tadi porous asphalt itu cuma satu layer, yang kita ada satu lagi jenis dipanggil double layer porous asphalt 2LPA. Or kalau dekat Europe itu dikenali sebagai with the name of twin layer. And then next one we have this hot roll asphalt HRA. But hot roll asphalt is very limited use, only used in UK lah, sebab agak mahal dan perlukan special equipment. And then lepas tu kita ada mastic asphalt, soft asphalt. Soft asphalt SA normally digunakan untuk negara-negara yang dingin lah, cold climatic countries, sebab untuk mengelakkan berlakunya cracking. And then the next one kita ada high modulus asphalt. So daripada sini biasanya kalau untuk yang atas kita gunakan conventional binder, but the rest kita akan gunakan modified binders lah. Okay, next. Okay, this is nak tunjuk sajalah these two figures shows the durability of surface layer using alternative surfacing materials, but this one is based on the European experience, so it can be summarized, it can be concluded that the SMA, hot roll asphalt and mastic asphalt can last longer for a long time as compared to other types of surface materials. Okay, ini saya cuma nak kongsikan sedikit Malaysian government policy, because most of the roads are paved using the flexible pavement. So this is the Malaysian government policy, where we were asked to build a new road using the concrete or rigid pavement, which is around 5%. And then another 5% of the new road must be used is new technology lah, such as the polymer modified asphalt. And then new technology or innovative asphalt is also encouraged. So like now we are using latex, getah sama Dr. Sri, latex or kaplam in the road construction. Next. So this is one of the example of the use of latex or chrome rubber modified asphalt. Normally in Malaysia specification, this one is very new. We just added in Malaysia specification in 2019. For this latex or kaplam or chrome rubber modified asphalt, this one we mix between latex and asphalt using the wet process. Whereas wet process, because actually we have two types of process. One is the wet process and the second one is the dry process. Ya, so tapi kalau untuk yang latex ni kita gunakan wet process lah. So, but kalau go back to the history, kita sebenarnya dah mula lama gunaan getah ni started since 1950s. Tetapi the technology was very slow. There's some roads paved using this latex, and then it's keep quiet for a longer time, and then come again, and then go down. I think because of somewhere in 2018, the kaplam price really dropped drastically. So the government is looking for the alternative untuk gunakan latex lah. So that's why dalam kita punya ni kita dah masukkan dalam Malaysia punya specification. Gunakan dua lah, kita masukkan satu latex and the second one is using chrome rubber. Next. So ini adalah contoh lain lah, there's a study by the Public Works Department where we use this waste plastic modified asphalt for road construction in some areas in Malaysia. For this, they use dry process. For this waste plastic, they use dry process to produce waste plastic modified asphalt. But sebenarnya kalau tengok sejarahnya penggunaan polymer modified asphalt ni telah bermula lah. Kalau di Malaysia tu kita gunakan di Kuala Lumpur International Airport, KLIA, where I think we use various types of polymer. The first one is we use the SBS. Second one is EMA, ethylene methacrylate, and then the third one is low density polyethylene. Untuk setiap ni lah, untuk SBS itu runway 1, EMA modified asphalt untuk runway kedua, and then the third one is the low density polyethylene adalah untuk taxiway. So ini cuma saya tunjukkan foto aja lah. The photo was taken before and after the construction of the plastic waste modified asphalt. They claim, this Public Works Department claim that after 1 year, they use this waste plastic modified asphalt. They found that the road is still in good condition, whereas for the conventional asphalt mixtures, after 6 months, they already found some cracking. 6 months. Tapi kalau tanya saya, jujurnya agak inilah 6 bulan sudah rosak jalannya. Itu. Tapi tak apalah, just kita nak tunjuk comparison. They say that after 1 year, when they use this waste plastic, the road is still in good condition. Cuma saya tak tahulah sekarang because of this COVID-19 banyak kerja yang tertangguh lah sekarang. Next one, kita ada satu lagi teknologi. Kita gunakan warm mix asphalt technology, or sometimes also known as a half warm mix asphalt, HWMA. Tapi untuk mengelakkan kekeliruan to mix, they just call as the warm mix asphalt. So when we use also, I can say this is a recent technology in pavement and gain lots of interest among paving technologies. When we talk about this WMA, we are talking about lower mixing and compaction temperatures around 30 to 40 degrees as we compare to conventional asphalt mixtures. Next. So this one is our experience before. We got involved with this warm mix asphalt project. This one is in south of Malaysia, in Johor. And then, but this one, the project is only for the rural area, for the low volume road. And then you can see that from the photo, you cannot see smoke coming from the construction site, because we are talking about 30°C or until 40°C lower as compared to the conventional asphalt. Until today, I was told that the road is still in good condition. Saya pun sudah lama tak pergi kawasan, tak tahulah macam mana. Next. I think another thing, quite interesting topics in pavement engineering we are going to talk about is about the pavement end of life ataupun recycling lah. So pavement end of life can be defined as a final disposition and subsequent reuse, processing or recycling of any portion of a pavement system that has reached the end of its useful life. So when pavement reaches its end of life, it may remain in place and reused as part of the supporting structures, be recycled and reused, most commonly case in particular for old asphalt known as reclaimed asphalt. Ini term dekat Europe lah, reclaimed asphalt pavement, ataupun kalau dekat US biasa digunakan recycled asphalt pavement. But we are referring to the same thing lah, ataupun kita remove and landfill. Next. So what's the advantage of pavement recycling? So first is the conservation of natural resources for aggregate production but also for bitumen saving. Second is about the energy saving, conservation of the environment, reduction of the construction costs. Next. Ini saya cuma mau share lah sedikit apa ni recycling activities in Malaysia. Actually, in our specification, we have two types of recycling activities. The first one is the hot in place recycling, HIPR, and the second one is cool in place recycling, CIPR. Of course, if you refer to, research, we have various types of recycling techniques lah. The first one is we have this hot in place recycling, hot in plant recycling, cold in place recycling, cold in plant recycling, and the last one is the full depth reclamation, FDR. So dekat Malaysia ni, kalau tanya saya suka bahagian ni, saya suka bahagian recycling. We are talking about this sustainability. Tapi this activities ni quite slow lah berbanding dengan ni. And then these figures, ini yang kami tengah cuba kaji sekarang. So yang mana we try to use the warm mix asphalt additive and then plus with the RAP, recycled asphalt materials in the road construction. At the moment, I think the best percentage that we can use this RAP, recycled asphalt pavement, is around 30 to 40% lah. To be mixed with the virgin materials. Sekarang masih lagi research masih lagi ongoing. So hopefully one day we can achieve to go up to 100% of the recycling material. But of course, if you maybe satu fakta lain, kalau dekat US, the most recycled material is asphalt. Next. So next one is just tips for improving sustainability from asphalt points of view. The first one is to use appropriate types of asphalt in each layer. It is recommended to use dense asphalt concrete for all asphalt layers except for the surface layer. And then the next suggestion is for the surface layer, use AC14, ACTL, or AC for very thin layers, ACVTL, or we can use SMA. If noise reduction demand is profound, and then of course we can use this porous asphalt. And then of course again the best one is to use polymer modified bitumen or polymer modified asphalt in those surface layers. And then also we can consider using HIMA, high modulus asphalt, in the binder course and asphalt base layer. And then we can consider to use a warm mix asphalt. And then again, the best also to use reclaimed or recycled asphalt pavement. Percentage incorporated is restricted by the availability of suitable mixing plant. Next one is we have this perpetual pavement. Tapi saya ingat kalau kontraktor tidak sukalah yang ini sebab jalan ini tahan lama kan. So kalau ikut dekat sini dia punya ketebalan adalah between 350 to 750 mm. So kalau kita tengok kita ada inilah dua definition. Satu dipanggil sebagai long life pavement (LLP). A long life pavement is a type of pavement where no significant deterioration will develop in the profound or the road-based layers, provided that correct surface maintenance is carried out. And then kalau dekat US dipanggil sebagai perpetual pavement lah, ataupun perpetual asphalt pavements, and asphalt pavement designed and built to last longer than 50 years without requiring major structural rehabilitation or reconstruction and needing only periodic surface renewal in response to distress confined to the top of the pavement. So normally dalam jalan biasa kita design around 10 to 15 years lah. Tapi when we're talking about this perpetual pavement, we are talking about dalam 40 hingga 50 tahun longer. Lebih lama lah yang ni. Next. So this is some advantages of using the perpetual pavement. Low life cycle cost by avoiding deep pavement repairs of construction. Also, lower user delay cost since maintenance or rehabilitation works require lesser times, hence shorter period of traffic disruptions. And the third one is lower environmental impacts since lesser maintenance is required over pavements, lifetime recycling may be applied. Next. So ini adalah satu lagi bidang yang quite interesting lah. Saya tak sempat nak cover semua within 20 minutes, but this one is also another interesting study to look into, known as the cool pavement technology. So this technology can be divided into two sections. The first section is dipanggil sebagai reflective pavements and evaporative pavements. Dikatakan sini, this technology is what we research and apply cool technologies, and the second one kita ada heat storage modified pavement research, but this one is what we research but rarely apply technology. Maybe because this one is more expensive or costly as compared to the first group. Ini yang quite interesting lah. I think we can look into. So to conclude, this is some conclusion. To construct a sustainable flexible pavement or an eco-friendly flexible pavement, the pavement must be durable and long-lasting. So life expectancy then more than 40 years. So if you refer to the American definition tadi, should be more than 50 years lah. Use high quality aggregate materials as close as possible to the project site. So ini yang kita boleh tengok case we can refer to the SMA 10 tadi lah. Project, use the appropriate bitumen or asphalt binder, use appropriate asphalt complying to the requirements, use not only empirical but also performance related properties requirement. So macam sekarang kalau tengok kalau biasa kita tengok tadi contoh penetration, softening point, ductility, all those conventional testings. But sekarang kita perlu tengok jugalah test-test yang performance related properties, such as kita study of rheology, study of flow and deformation of material, tengok viscosity gunakan profile, PPR, bending beam diameter, so on and so forth. And then use proper pavement design methodology to derive alternative solutions based on the final decision solution on the LCA life cycle cost analysis or economic evaluation and life cycle assessment environmental impacts result without being influenced by the initial construction cost. Of course, when you are talking about the initial cost, bila kita gunakan teknologi baru, harganya akan lebih mahal lah as compared to the conventional one. Tapi kita bercakap tentang banyak perkara lah. Kita bercakap tentang economic evaluation, we are talking about the environmental evaluation, then we can make a fair judgment. So use best compaction practices, in particular to those related to compacted density, locking the transverse joints and evenness, use latest technology, construction equipment and transport vehicles. This one is as mentioned by Professor David. Next. So Plan the time of the year for execution of major construction works and the days or periods within a day for maintenance and rehabilitation works. Ini particularly kalau untuk negara yang four season countries, bila kita gunakan sebagai contoh warm mix asphalt technology, because we are talking about this lower mix and compaction temperature, so we have to plan. Kita kena plan lah untuk construction. Kalau negara-negara yang four climatic countries ni dia akan buat constructions normally particularly pada summer time. Tapi kalau mungkin dalam case kita like in Indonesia, in Malaysia, I think benda itu bukanlah satu masalah besar lah. Provide an even pavement with good structural responsiveness, having a surface layer possessing good and long-lasting surface texture and good and long-lasting permeability. Apply proper and timely maintenance. Of course, maintenance must be done at the proper time. Considering not only cost and performance, but also environmental and social impact. Consider end-of-life pavement as useful asset, which must be reused. So maksudnya kita go for the recycling. Encourage the use of reclaimed asphalt or recycled asphalt pavement in hot or warm recycling, cool recycling primarily in asphalt maintenance and rehabilitation works, as well as in construction of unbound layer. So at the end of the day, a sustainable pavement certainly requires more capital to build, but on the long run, it is economic, friendly to the environment, and better for the society. This is some of the reference that I use to prepare this slide. Dengan itu saya mengakhirilah saya punya sesi. Apa yang baik itu datangnya daripada Allah Ta'ala dan apa yang buruk itu datangnya daripada saya sendiri. Thank you very much indeed, and Assalamualaikum warahmatullahi wabarakatuh. Thank you. Minta maaf, ini first time saya bagi itu agak komentar sikit.
Thank you, Prof. Izzy. It's very interesting presentation. Dan topik ini sebetulnya satu semester ya, because quite interesting topic, and we look from the presentation. There's so many idea we can create, or we can start the research in sustainable pavement technology. And the important thing that already mentioned by Prof. Izzy is a sustainable pavement requires the more capital to build. I mean, investation. I mean, don't need the money, more money to construction, investment, and so on. But it is a long run in the economic, environmental friendly, and better for society. That's a good point related to our conference, because our conference is trying to looking for the idea how to build our society and our earth with environmental technologies, good for society, and give the better life in the futures. And now I open the question and answers session to the floor. If you have any question to Dr. Izzy, Prof. Izzy, please raise your hand. I starting from the right side of mine or left side of mine, please. Any questions? And Dr. Izzy also give the experience, pengalaman, informasi-informasi terkait dengan bagaimana sustainable pavement technologies implement in Malaysia. Karena itu sangat menarik sekali, karena kita pun memiliki same climate, ya, temperatur yang sama, cuaca yang sama, material also almost same, I think, ya, karena kita negara yang berdekatan sekali, dan problem daripada traffic pun relatively same. So it's very interesting topic to discuss with the Prof. Izzy, the experience in Malaysia, masalah-masalah yang mungkin timbul dalam implementasi sustainable pavement and so on. Please, Monggo, satu dari sebelah kiri. Sebelah kanan. Mas Ayus. Oke, monggo. Please.
Thank you, Mr. Sri. Mohon izin. Prof. Izzy, I want ask just one question, not five. In some project in Kalimantan, especially in national road, we build some road to support the IKN, and they use latex asphalt. So I want to know about the latex from your opinion, because you say some this asphalt sometimes famous, sometimes hilang gitu. In our iklim yang gampang berubah itu sebenarnya perilakunya seperti apa? Jadi the characteristic, is this good asphalt or bad asphalt to use in our iklim? Thank you very much.
Thank you, Dr. Marini. I think actually, like in our case, yeah, we try to overcome this rutting problem at high temperature, and then also this fatigue problem at this intermediate temperature. So it means that we need something, the method that is hard, but at the same time it is elastic. So nak gunakan material apa itu kita kena tengoklah dia punya result nanti. So at the end of the day kita nak overcome these two problems, like in our case. Saya nak bagi tahu, but I think from research to use latex is good, but maybe again when we are talking about the initial cost, cost awalan itu yang agak mahal, it's quite expensive, and then I think the contractors mungkin reluctant lah to invest more money. Itu yang kita nak kena overcome dulu lah sekarang ni. Jenis material tu depend on, we can study and then we can check. Even when, for example, when we talk about the polymer modified asphalt, so normally the supplier won't reveal what types of polymer that they use. At the end, they just shows the dia punya result lah. So and then we make comparison with the conventional bitumen. Tapi kalau dalam case kita ini, kalau tanya saya, latex itu is good lah, boleh pakai lah. Cuma initial cost will be much more expensive. I think one more thing is contractor doesn't like it because means that long-lasting road means that no maintenance job. Itu yang susah sikit lah. Itulah jawaban saya.
Oke, terima kasih. Ada pertanyaan, Dr. Marini? Sudah? Oke, please, Dr. David.
Yeah, this is more a comment. You said about limestone not being used in your country. I know there's a lot of limestone in this part of the world, but we were involved in the construction of the F1 circuit in Miami and in Florida, in the US. The only aggregate they have in the whole state of Florida is limestone. And whenever we were looking into the suitability for Formula One, we discovered that the local limestone there has got really good skid resistance. Now, I don't know if that's a similar survey has been done in this part of the world, but there are two types of limestone that can give good skid resistance. And in the evaluation work that we did, it performed better than granite, the local granite. And in the end, we surfaced the track in Miami with a blend of local limestone and local granite, and then work on the differential wear between the two aggregates to maintain texture and wet skid resistance. So I don't know if it's something that you've done in this part of the world, but there is a possibility for some types of limestone to be good for road surfaces.
Thanks, Paul. Because normally here, I think the rumors is, I can say that rumors is when we use the limestone, it's gets polished faster as compared to the granite. So that's why when I talked to this Professor Halen Shelan from Iowa State, and then he disagreed with me, and then he said that his experience is like what you said before.
I would agree with the person you talked to. There are some limestones out there that perform better than what they should do. It's all about in-service performance. A laboratory test is not always the answer. You have to think about performance on the road.
Okay, one more question before Prof. Izzy should prepare go to the airport. I think your flight is. Okay, one more question, please. If you have any, Dr. Sifrit.
Thank you, Pak Sri. It's just a simple question. You're talking about the long life pavement. Long life pavement. Is it the same because when I read from some paper that it seems to me that long life pavement is something like full depth pavement. I don't know why, but I get impression that long life pavement is something similar to the full depth pavement. That's the first question. Second one is, have you Malaysia applied the long life pavement, or how the performance say that 5 or 10 years after the first open traffic? Thank you.
Thank you, Doctor. The first question, I think maybe some researchers, they use different term. Maybe you're talking about full depth pavement. Maybe they are referring to this perpetual pavement as well. Maybe I don't know. Maybe Prof. David can answer. For the question, second question, the answer is no. So I cannot comment on that. Maybe Prof. David can. I don't know about this. We have no experience. I think it's because the problem is as I mentioned before, this one is out of record. When they use this plastic waste, and then they say that when they compare with the conventional asphalt mixtures, they say that the plastic waste can last long. After 1 year, they say that the road is still in good condition. But when we comes to these conventional asphalt mixtures, after 6 months, we can already see the cracking. So it means that the quality is very bad for the very low for the conventional asphalt mixture. Sorry, doctor, I cannot answer the second question because my answer is no. We don't have that one. Thank you.
Thank you, Prof. Izzy. Dr. David, do you have any comment about the perpetual pavement?
Mike Nunn from TRL, and Mike was one of the early people that talked about a pavement we should be designed for a long period of time. So in the UK, that idea is we build a thick structural layer, and then the top thin layer, that's a sacrificial layer. We replace that regularly. But the key thing is you spend the money, you invest in the thick structural layer, and then the top layer. Now, in the UK, we do not have a lot of opportunity to do that because our motorway network, our heavily trafficked roads have been built for many years. And because they're so heavily trafficked, it is almost impossible to go back in and remove the complete layers and start from the subbase. That is almost impossible to do. So a lot of work that we do in the UK is that top layer. And we go back and we go back and we go back and fix that top layer many times. So it's just the way things are in the UK now. We've got this sort of problem of an old road network that needs totally replaced. But the money involved is totally massive. So we're just involved in that top layer, and a lot of the work that we do in recycling and old road materials, old surface materials, old aggregates, but there's a lot of technology has been developed. If a road's going to be recycled, we go out and we core. We take cores, we go back and we analyze what is the top layer, what's the properties of it, is the aggregate still good, is the bitumen okay, and then we develop a mixed design based on the different roads that are being replaced to then get recycled.
Okay, thank you, David. I will continue. I want to continue the question and answer session, but the committee has already asked me to to stop. Thank you, Dr. Izzy, for your very interesting presentation and many knowledge that information that I receive and we receive, and I think it's very good for us to continue this discussion to be what we call the collaborations in the research, in the project, and many activities that we can create after this conference. Please give applause to Dr. Rizzi, and thank you very much for our the opportunities to lead this session, and I give the time back to Burisa.
Okay, thank you for keynote speaker and the moderator for the second session. Give an applause, big applause for Self-Ground. Before we move on to the break, for keynote speaker and moderator, we would like to ask the keynote speaker and moderator to the podium, and committee would like to present the ceremonial gift to you all. Okay, I'm sorry. Now to the next section. We would like to present a traditional dance from East Kalimantan, on which beautiful and delicate moves symbolize our dedication to welcome everyone with warm hospitality and respect. We present you Tari Ledoh Menyut.
Tari Ledoh Menyut. Ledoh means girl or woman, and Menyut means washing with a movement that simulates someone washing followed with a cloth. The Ledoh Menyut dance illustrates the traditions of Dayak Kenya females who go to the river every afternoon to wash clothing with much enthusiasm. It also explains about the essence of a woman's connection in mutual collaboration and kinship.
Ah
Thank you for the dancer for the lovely dance. The next agenda, we would like to ask keynote speaker into the podium, and committee would like to present the ceremonial gift to you all. Please come to the podium, and it will be given by our chairman, Mr. Lucky Caroles. Okay, please, for the keynote speaker, move forward to the podium. The committee would like to present the ceremonial gift to all keynote speaker for today. And they are given by our chairman, Mr. Lucky Caroles. And to the moderator to give the symbolizing. The first ceremonial gift given by Mr. Lucky Caroles into Mr. David. Thank you, Mr., for sharing your expertise in this session, in the conference. Okay, let's take a picture. Give it an applause. Okay, the second. Okay, give an applause. Let's hear from Prof. Easy. Okay, let's take a picture first. Okay, give an applause. Okay, maybe three of you, keynote speaker and all the committee will take a picture together. Okay, thank you for sharing your expertise in this conference. Oh, okay. Okay, only for the three keynote speakers will take a picture together. And the second ceremonial gift will given to Civil Engineering Department from Universitas Hasanuddin and Civil Engineering Department Universitas Balikpapan. To Professor Sumani, please come forward. It will be given by Mr. To Prof. Sumarni. It given to Prof. Sumarni from Universitas Hasanuddin. It will be given by our chairman, Mr. Luki Caroline. Give an applause. The second one is for Mrs. Maslina from Universitas Balikpapan. Thank you. Okay, our audience. Dear all audience of this conference, for the next session, the attendees are welcome for lunch and break. Lunch will be served in the lounge area in the lobby. So you can come down to the lobby on the first floor, and now we can back to the venue at 1 p.m. Dipersilakan untuk para hadirin untuk menikmati santap siang beserta istirahat untuk sholat. Makan siang sudah dipersilakan, sudah dipersiapkan di lobi di lantai 1, tinggal turun ke bawah ke lantai lobi dan dimohon untuk kembali ke venue pada pukul 1 siang karena kita akan melanjutkan acara parallel discussion. We'll give you lunch and break for 1 hour. Lunch will be served in the lounge area on lobby. You can come down to the first floor or lobby floor. And we'll be back here in the venue at 1 p.m. Thank you.
Banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri. Dalam kasus penyediaan teknologi ini.
masih banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
Masih banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
tes 1 2 dicoba. Iya. Tes 1 2 dicoba. Tes 1 2 dicoba.
Masih banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
Masih banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
Masih banyak yang harus dilakukan penelitian untuk teknik sipil itu. Sebenarnya itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
Masih banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
Masih banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
masih banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
Masih banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
Masih banyak yang harus dilakukan penelitian untuk teknik sipil itu. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
teknisi PU. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
banyak yang harus dilakukan penelitian untuk teknisi PU. Cuma itu satu. Terus yang pasti.
Makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah di negara kita sendiri dalam kasus penyediaan teknologi ini.
yang harus dilakukan penelitian untuk teknis itu. Itu satu. Terus yang pasti,
makanya jiwa-jiwa mahasiswa atau engineer muda nanti ini harus bersifat fighter seperti itu.
Jangan menjadi fighter tanpa persiapan. Mulai dari sekarang harus menambah ilmu, menambah wawasan.
Kita harus jadi tuan rumah pada proses pendidikan.
Good day, ladies and gentlemen. For the next session is parallel discussion. All participants will set it as written in the paper. If the participant has not get the chair number, you can ask the committee to give you the number of room. Ladies and gentlemen, for the next session is parallel discussion. All participants will set it as written in the paper.
Heather? Yeah. Okay. You're welcome. You're welcome.
Maksudnya apa komiknya?
Good afternoon, ladies and gentlemen. We are about to closing our conference today. All audience, please become to the Ladies and gentlemen, the conference is about to end. All of the audience, please back to the venue. Before I close this conference, we will hear the closing statement from Professor Herman Paru. Time and place is you.
Good afternoon, everyone. I'd like to say thank you to all of you for your good participation for this first conference. As mentioned before by our rector, Professor Jamaluddin Jompa, this is the first international conference, but it is hoped that it is not will be the last international conference. Because of that, I would like to ask you again that maybe if you have time, you can join this conference next year. I don't know whether it will be held in Bali or Yogyakarta or in other place. But I think the organizing committee would like to have you all to participate again in this conference. And as mentioned also before by the rector of Universitas Balikpapan and Universitas Hasanuddin, and I think also the representatives from other organizing committee, maybe from UMY, Universitas Muhammadiyah Yogyakarta, Anglang Buana, and also Balikpapan. Okay. They all said that this is the first conference, and then it is hoped that it will be expanded next year, and we hope that next year we will have more participants and more articles that can be published in our maybe international proceedings. And normally in Indonesia, I forget your name. In Indonesia, normally we will have all proceeding articles to be published in international journals or international proceedings. And it is also expected from all the organizing committee that all the presented articles this afternoon today can be published in our international proceedings, which will be indexed in Scopus Index proceeding. With that, I would like to thank all of the invited speakers, keynote speakers, and all the participants for joining this Press International Conference. And I think it is better also for me to say my good appreciation to all the organizing committee. We have Pak Luki, we have Pak Sakti, and other organizing committee, and also the, I think, students from UNIBA, and also from PU. All of you have contributed to this great success of this international conference. With that, I would like to officially close this international conference. Thank you very much, and see you again in the next week. Thank you.
And here is the end of the conference. Let us be guided by all the things we have learned and heard throughout the conference, and be able to see and influence our future. Me, as representative for the conference committee, Raisa Fadila, deeply apologizing if there are any mistake. Thank you so much for your attending. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh. kepada para hadirin, untuk acara besok hari yang akan ikut ke IKN, dimohon untuk mengkonfirmasi kembali kehadirannya atau keikutsertaannya dengan menghubungi Mas Bayu atau di kontak di grup yang sudah ada ya Mas. Untuk yang ikut ke IKN besok sudah berkumpul di sini pukul 6.30. Ini sekali lagi untuk yang ikut ke IKN besok dimohon untuk mengkonfirmasi ulang keikutsertaannya dan sudah ada di sini pukul 6.30 atau untuk lebih jelasnya bisa menghubungi Mas Bayu. Terima kasih.